Good afternoon, happy Holi to all the JEE students. Welcome aboard to the Vedantu JEE English channel. And we are keeping up with the 1 week challenge where we are going to solve lots of questions for you. And today's session is the 11th standard physics questions. So we'll solve, maximum questions as much as possible. And you have to keep the Josh high. And you will learn a lot of things which otherwise you would not have done. Somebody needs to always push you. Somebody needs to, always make you sit down and, help you solve the problem. So here I am just before the exam. So making sure that you guys solve the problems. Just a quick reminder or a recap of what this 1 week challenge is. There will be 100+ problems every class. So 4 classes in 2 days, that is today and tomorrow, completing the 11th standard syllabus problems. So that's 400 problems. Similar session on Thursday and Friday, 400 problems of 12th. 11th mock test a day after tomorrow on Wednesday, 12th mock test on Saturday, and full syllabus mock test after all of this. So totally 1000 questions we are going to complete in a matter of this particular week. And if you want to take more help, remember, you might be probably in a city where there is already a Vedantu Learning Center present, where you can get complete guidance, mentorship, also your doubts cleared with the amazing teachers at those centers. So in fact, even I was at one of these centers just recently, be it Pune, be it Hyderabad, and now I'm going to Bangalore and Chennai too. So make sure that if you can take help and you need that motivation, that guidance, or how to crack the exam, visit the center. And if you have your juniors or your batchmates who are looking for something and looking for an offline batch with the best mentorship, with smart classrooms and world-class facilities, and you will see why Vedantu offline centers are way different than any other coaching center in your area. So we are already spread out in many cities, and classes are running full-fledged. So I was in Hyderabad and I saw so many batches running, for the JEE and then for the next 10th moving 11th standard students, and so on and so forth. So make sure you too are a part of this revolution. And yes, there is an amazing event which is happening, a grand event in Patna. So if you are in Patna or if you know someone in Patna, do let them know, because there is a big grand event happening with all the best of the best teachers coming in Patna for this mega event, right? So be there. All right, so I think the venue is also mentioned. March 31st is the date when it's going to happen, 11 o'clock onwards. It's in Samrat Ashok Convention Center. Okay, right. So let's start with the questions. Get ready, my dear students. Video and audio not syncing. Why? Just check if it is syncing right now. Just see if it is syncing right now. Hello, my dear warriors. Can you see me properly, hear me? Just let me know. Now it is fine? Yeah, now it is fine. Okay, great. Let's go ahead with the questions. Remember, you also need to open your rough sheets and simultaneously you can make running notes or running problem solving is what I would say. All right. Okay, if you just want to see, that is also fine, but after the class is over, try to solve the same problems on your own and see how much you are able to do. Here is the first question. The length of a sheet is there 1.5 centimeters and the breadth is 1.203 centimeters. What is the area of the sheet to the correct number of significant figures? Now the rules when you basically multiply or basically divide is you always choose the minimum. You will always choose the minimum of significant figures, minimum of the 2 significant figures, right? That is how the rules go when you are multiplying or basically dividing. If you notice over here in 1.5 centimeters there are 2 significant figures, 1 and 5. In this one you can see 1 2 0 3 1 2 3 4. There are 4 significant figures. The least significant figures are there in this. So the final answer should have 2 significant figures. Even without you having to actually multiply 1.203 multiplied by 1.5, which will give you something, but you will round it off to the correct significant figures. You should see the options. This has many significant figures, this has many significant figures, this has many significant figures, this has exactly 2 significant figures. None of these options have 2 significant figures. So even if they are more accurate, but using the rules of significant figures, they do not make sense. So just directly mark this as 1.8. The exact answer will not be 1.8. That is not the point. The rounded off value to the current significant digits has to be in 2 significant digits only. Did you get it, everyone? Yes, Rahul Patel, I'll be definitely taking up EMSAT classes as well. Moving on to the next question on your screen. But for now, please continue with these classes. Definitely there is something amazing coming up for 11th moving 12th, 10th moving 11th, as well as EMSAT and other exams like BITSAT. So many things are there. We'll take care of you. But let me tell you, these questions will also help you for any other exam like BITSAT, VIT, EEE, EMSAT. Okay, so attend these questions. You will definitely not feel that, you know, this is out of context. This is properly there in the syllabus. The pressure on a plate is measured by measuring the force and the length of the sides. If the maximum error of the force and length are 4 and 2%, what is the error in the pressure? There is some problem with the force and length measurement. So there will be obviously some error in the pressure measurement. So first of all, realize how is pressure related to force and length. The length of the plate is given. So I can find the area, and we know force per unit area is the pressure. So I will start off with that. Pressure is nothing but force divided by area, which is force divided by length square, which is force raised to 1, length raised to -2. Why did I write it like this? Because there is a simple error formula which says the net physical quantity is relative error. That means delta P by P, let's say percentage, will be, take the first physical quantity, let's say delta F by F, take the relative error, multiply it with the power. The power is basically 1, that's it. Then add to it the next relative error, which is the relative error of the length, and multiply it with the mod value always of the power. So it is basically 2 into and then percentage error. That's all. So that will give you the answer, my dear warriors. The percentage error in the force is nothing but 4% plus 2 into the percentage error in the length is 2%. So 2 2s are 4, 4 plus 4 is basically 8. So the answer is going to be 8%. Very good. Many of you got it correct. Very good, Mihar. Very good, Yashwant, Karthik. So many of you have got the correct answer. Proud of all of you. Moving ahead to the next one. The density of a material in CGS system of units is 4. In a system of units where the unit of length is 10 and the unit of mass is 100, the value of the density of the material in that new unit will be how much? So this is a question on conversion of units, where you convert from one system to the other system. Many people try to remember that formula N1U1 is equal to N2U2, but there are some confusions which happen when you use the formula. So a better way I will tell you, what you need to find is density. We know density is nothing but always mass per unit volume. Volume is basically having the dimensions of length cube. So dimensionally, density is mass per length cube. That's all you need to convert from any system to any system. Whatever physical quantity is there, at least know the dimensions of it, or you can find out the dimensions using some formula which you know. Now, what is it that is asked? You have to find what is the density in that particular unit. In CGS, you know. So think about it. The density in those units will be 1 unit of that mass, 1 unit of that mass upon 1 unit of basically the volume, which I can write it as 1 unit of that particular mass upon volume is nothing but length cube. We know that. So it is basically 1 unit length whole cube. All this I got to know because of the dimensions. Density was relatively easy. Let's say it was resistance or thermal conductivity, etc. Then you need to know the dimensions so that you can write this. according to the dimensions. Mass was there, numerator. Length was there, denominator. It was cubed, so I'm cubing it. If the dimensions were different, this would also look slightly different. The powers, their numerators, denominators will change accordingly. Okay, so what is 1 unit of that mass? Think about it over here. Unit mass is 100 gram. A unit mass is basically 100 gram. So can I not say this is basically 100 gram over here? 100 gram over here. Unit length is 10 centimeter. So 1 unit length, can I not just put it as 10 centimeter, and this will be basically cube. So this will be 100 divided by 10 cube is basically 1000. This will be gram per centimeter cube, my dear warriors. Zero zeros will cancel. So won't it become 0.1 gram per centimeter cube? 0.1 gram per centimeter cube. So think about it. 4 gram centimeter cube is asked. 4 gram centimeter cube is asked. Just move this 0.1 over here. So 0.1 units, 0.1 comes on this side. It will become 10. 10 units of density will be 1 gram per cc. 1 gram per cc. If I take the 0.1 on this side, it will become 10. 1 by 10, 10 goes on the other side. So this is 1 gram per cc. So my dear warriors, what will be 4 grams per cc? Just multiply by 4. Won't it be 40 units? 40 units of that density. Won't it be just 40 units of the density, which is option C? How many of you got it? No, it is not B. Many of you made a mistake over there. Many of you said B option. Many of you said B option. That is wrong. So just to give you a quick reminder of how we converted the units. Whenever any quantity is given, let's say for example, it was some random physical quantity and the dimensional formula is m1 L square t raised to minus 2. Example, just taking some example. And I tell you 1 unit of mass is basically 10 gram. Then I tell you 1 unit of length is basically 0.1 centimeter. And I tell you 1 unit of time is, let's say, 100 seconds. Example. So how do you convert it? Just if I write down 1 unit of that particular physical quantity, what will you do? Mass is raised to 1. Mass is raised to 1. So basically 1 unit mass, this is raised to 1. Length is raised to 2. So 1 unit length raised to 2. Time is raised to minus 2. 1 unit time raised to minus 2. What is 1 unit mass? 1 unit mass is 10 gram. What is 1 unit length? 0.1 centimeter square. What is 1 unit time? It is 100 seconds raised to minus 2. That's all. Now just take the numerical part separately. 10 into 0.1 square into 100 square into 100 square into gram centimeter square second raised to minus 2. Some physical quantity. So what will happen over here, my dear warriors? This will become 0.1 and this will become 10,000. So it will basically become 1000 over here. 1000 gram centimeter square second raised to minus 2. So this is how you converted 1 unit of that quantity into CGS unit. It could be done in MKS or any other unit. Got it, my dear warriors? How this has to be done? Only if you know the dimensional formula, you can convert from any system to any other system. If you know the dimensions, just substitute 1 unit mass, 1 unit length, 1 unit time, 1 unit this is how much in MKS or CGS. If you substitute, take care of the numbers separately, automatically you will get the conversion formula. The moment I got this, I know question was 4 gram cc. 4 gram cc multiply by 4, you got the answer. Yeah, got it? Time power is minus 2. Oh, so sorry, time power was minus 2. My bad, I missed that minus 2 over there. I just wrote it as 2. Yeah, this would be minus 2. So this would technically be 0.1 divided by, or rather you can put this as 4 zeros over here. So this will just become 10 to the power minus 5 gram centimeter square second raised to minus 2. Yeah, correct. So this was gram centimeter square second raised to minus 2. The power was minus 2 there. Correct. All right. Moving on to the next question. Two equal vectors have a resultant equal to either of the two. Then what is the angle between them? Two vectors, you add them. The resultant is equal to either this or this. So what do you think was the actual angle between the two vectors? Multiple ways to do the problem. One way is formula, other way is just geometrical approach. So think about it. If the vectors have same magnitude, that means it must be an equilateral triangle. It must be an equilateral triangle. So think about it. This vector plus this vector might be giving you this resultant vector. This resultant vector, just think about it. This is your resultant vector, and the other two, A bar and B bar, are your vectors being added. It should be an equilateral triangle. It is an equilateral triangle. Only then this can happen. All the magnitudes are equal. Remember that. This magnitude, this magnitude, this magnitudes are same because it is given equal to either of the two. So question is, what is the angle between A and B? A lot of you will say 60, but be careful. Always angles have to be measured by keeping their tails together. By keeping their tails together or heads together. So if this is A vector and this is basically your B vector, you can see the actual angle will be 120 degree. Take this vector, slide it. Take A vector, slide it. Actual angle is 120. It is not 60. Many of you wrote option B, which is wrong. You will get -1. Many of you will get -1. Be very, very careful. It is not B, it is C option. Always keep the tails or the heads to measure the angle. Have you understood it? If you had not attended this class, you would have lost many marks. This is what happens in the exam. And I want you to precisely, get those marks which you are otherwise going to lose. I want you to, keep a hold of your marks, because negative marks is the biggest enemy in the JEE exam. It will just snatch away whatever you know. It will just take away whatever you have gone. So be very careful. Is that okay? So keep this in mind. Always angle between the two vectors is measured. So if I have one vector here, and let's say another vector here, don't measure this angle. Or if I have one vector here and let's say another vector here, don't measure this angle. Always measure either when both the tails are together, then you can measure it, or both their heads are together. Doesn't matter. This angle is also okay. This angle is also okay. Never measure like this. Never measure the angle like this. That is how the angle measurement in vectors has been defined. Right? Understood? Okay. Another way of doing the same question would have been, you can say formula for resultant is nothing but a square plus b square plus 2ab cos theta. RAB, everything is same, so it will be x square is equal to x square plus 2 into x into cos theta. This will also do. I can assume all the quantities are basically x. So x cancel, so 1 will be 1 plus 2 cos theta. 1 cancels, so it will become -1 is equal to 2 cos theta. So basically cos theta is -1/2. That means theta must be 120 degree. This way also you will get the same answer. This is numerical approach. This was geometrical approach. Okay, both the methods I have told you. Is that okay? Yep. Awesome. Saiti, I hope you understood this. Yes, this will be available, Srishti, after the session is over. After the session is over, you will be able to see the recording also. Definitely. Moving on to the next question. Coordinates of a moving particle is given by x is equal to 2t cube, y is equal to 3t cube. Okay, 2t cube, 3t cube. Acceleration of the particle is given by what? Okay, let's see if we can solve this. First of all, from position to find acceleration, you will have to differentiate it two times. First derivative velocity, second derivative acceleration. If you look at x over here, x is basically 2t cube. The velocity in the x direction by just taking the derivative of this, will just give me nothing but 2 into 3 into t square, which is basically 6t square. So the acceleration in the x direction will be, take the derivative of 6t square, take the derivative of basically 6t square, it will be nothing but 12t. Next point, same thing, y coordinate is 3t cube. So velocity in the y direction will be just the derivative of this 3t cube, right, in the y-axis, you are going to get the y velocity. So this will be 3 into t square, which is 9t square. The acceleration in the y direction will be the derivative of this. Derivative of velocity gives you acceleration. So this will be 9t square. So this will be 9 into 2t, which is basically 18t. I got ax, I got ay. What is the last step going to be? So the total acceleration will be nothing but 12t whole square plus 18t whole square. 12t whole square plus 18t whole square. Many of you are saying option B. Is that right? Pakka? Done? Block? Yes, option B is blocked and it is correct. Root 468, time comes outside. So this is what you will get. Understood, my dear students? This was a two-dimensional problem also of non-uniform motion because the coordinates were dependent on time. Whenever you go from position to velocity to acceleration, you differentiate. If acceleration was given and velocity was asked, you integrate. From velocity, you integrate again, you go back to position. Okay, the reverse process will be integration. The forward process will be derivatives. Cool? Let's move on. Two projectiles are thrown, same speed but different angles to the horizontal. Which is wrong is the question. Which of them is wrong? Read the question carefully. Two projectiles are thrown at 60 degree and 30 degree. So, realize one interesting thing. They are both complementary angles. 30 degree and 60 degree are complementary angles. So, ranges are equal for complementary angle. So, first option is definitely correct. Ranges are same. Ranges are going to be same for complementary angles. Like 20, 70, right? 45, 45, 37, 53, 30, 60, 10 degrees, 80 degrees. These are complementary angles and ranges are same. So option A is correct, but the question is which is wrong? In the exam, if you don't read this word, you see this as the option, first option, you will mark it and you will move ahead without even realizing you have committed a grave mistake. So be careful, it is wrong which is asked. Okay, height and time. If you compare the height formulas, height formula is nothing but u square sine square theta by 2g. Basically, height is proportional to square of sine. So HA by HB will be sine square 30 by sine square 60. What is it? Sine 30 is half square is 1 by 4. Sine 60 is root 3 by 2, square is 3 by 4. 4 cancels, it will become 1 by 3. So 3 goes on the top. So 3HA will be basically HB. 3HA is equal to HB. Yes, B option is also correct. Interesting. I think if B option is correct, most likely C option will also be correct, but we cannot just chumma say it. We have to find it out. Time of flight is 2u sine theta by g. Time is directly proportional to sine theta. So time A divided by time B is sine 30 divided by sine 60, which is 1 by 2 by root 3 by 2, which is 1 by root 3. So take root 3 on the top. So root 3 into time A is equal to TB, you take it on the top. So root 3 TA is TB, which is C option. That means none of this is wrong. Got it? What a brilliant question. So they can check really your patience. They can really check whether you are reading the question properly. And it's also going to test whether you remember all the projectile formulas. These kind of questions, highly probable. All the graphs below are intended to show some kind of motion, but one of them is not matching with the rest of the three. Which one is that? You decide. So pick it up. 3 of them mean exactly the same thing, just the y-axis, x-axis are different, but they are showing the same thing. I don't know which one are them, but one does not match with the others. Which one do you think it is? I'll give you a hint, my dear students. I think this graphs are most likely suggesting a motion under free fall, where you have thrown an object up, it goes up, stops and comes back. So if you realize that, it becomes very easy, right? No, Sumati. By seeing the first option, can you confirm it is D? For example, just imagine in this previous question, just imagine, it came out to be √3 HA is equal to HB. Imagine after solving, this is not what comes, this comes. Example. But here it says HB is 3HA. So then B option will be marked. So there is no other way but to actually check the first three options. Just because A is correct does not mean D is going to be marked as the option. Who says option B and C are correct? Maybe one of them is wrong, right? So you have to verify it. Cool? Clear? Don't do these mistakes. Guys, over here, what you need to do, understand, is if I throw a ball up, it goes up, velocity reduces, stops, and it returns back and hits the ground over here. Now realize one thing, the speed is reducing, and then it changes the direction. So velocity was earlier positive, then it has become negative, and here it has become 0 at the topmost point. So yes, B option graph is correct, matches it. If you look at velocity versus position, that is also fine. Velocity was positive, then it was negative. This is where you are at the topmost position because this particular length is telling you maximum height. This is telling you maximum height. Its position, a graph on the x-axis. Be careful. Position time, the position increases, stops, and then comes down. So this was the topmost position, and this is where you again come back to the same point. You started over here and the position came back to the same thing. So this also is matching with this description. What about this distance? Distance slowly increases and then stops increasing. I feel the manner in which this graph is drawn doesn't make sense to me. I'll tell you why. Here the slope is less. Here the slope is less, then the slope increases, and then the slope increases even more. This is not acceptable. How is the slope increasing? Actually, the speed is decreasing. The slope should also have decreased. So the slope is increasing, which is not correct. Hence, the D option is not matching with the rest of the three. The slope should have decreased. So actual graph of distance, how it should have been means, if it was distance graph, actual graph, how it should have been means, it should have gone like this, and then it should have gone like this. It should have gone like that. Okay, the distance rate will decrease because the velocity is decreasing. It becomes 0 at the topmost point. The slope becomes 0, and then again it begins to increase because the speed increases. So the graph goes up like that. So this would be the correct graph. This is not the right graph. Got it? Okay, everybody, very good, Meghna, very good, YT Gaming, excellente Kamini, very good, Kondini, awesome. Keep it up. Moving to the next question on your screen. Two balls are there, equal masses are there, you are throwing it up, same line, and after 2 seconds gap, same speed, then they will collide at which height is the question. See, if one of the ball is thrown up like this with a speed of, let's say, 40 meters per second, it goes here, and while it is coming, maybe it collides. So it has traveled for t seconds. The other ball was also thrown at 40 meters per second, but after 2 seconds. So it will collide after t minus 2 seconds. Why t minus 2 seconds? Because after 2 seconds it has been thrown. So take away 2 seconds out of the total time. That is the only time for which the second ball is in air or is traveling, is in motion, is in flight. Is that agreeable? Everybody understands this? The first ball was in air for t seconds. After 2 seconds you throw the next ball. So the next ball will have to remain in air only for t minus 2 seconds because 2 seconds you have delayed it. So this is the first piece of a drawing that you will be doing. And then what is same for both of them is their y coordinates, the displacement in the y direction. S is ut plus half at square. U is basically 40 into t. plus half into acceleration is basically minus g into basically t square. Same thing you can say displacement in the y direction will be 40 into t minus 2 plus half into minus g into t minus 2 whole square into t minus 2 whole square. These both are going to be equal. All you have to do is just solve them. Just solve them and find the value of time. Once you find the value of time, what you do is find either sy or sy from here. So sy will be 40 into whatever time you get plus half into minus 10 into that time square. Just see it, what do you get the answer as? Just see what do you get the answer as. Just check it out. Yep, just check if you are getting it as 75 meters and the time value as 5 seconds. You should get the value of time as basically 5 seconds. So this 5 you will put it here also and 5 you will put it here also. So substituting both of them, you will get the answer as 75 meters. You will get the answer as 75 meters. Have you understood the process, my dear warriors? Yeah, Meghna will be starting very soon. Very soon. Just give us some time. Right now, you know, JEE Mains is also round the corner. So after close to JEE Mains, you know, once the papers begin to go one by one, we'll slowly start preparing full-fledged for EMSAT also. Okay. So for now, your preparation for JEE Mains also helps you for your preparation for EMSAT. So, or any other CET or any other exam like VIT EEE or BITSAT, because the syllabus is the same. The same question can be asked in EMSAT. If I just put over here an EMSAT session, you'll be like, oh sir, yeah, this is EMSAT. But remember, we'll have separate sessions apart from this as well. All right, cool. Moving on, the trajectory of a projectile projected from the ground is given by this equation, where x and y are measured in meters. The maximum height attained by the projectile will be how much? Okay, that's the question. In here, both are equal because they collide. The question said with where they collide. They collide. If they collide means what? If they collide means what? Their displacements are equal. Their displacements are equal, right? Their displacements are going to be equal, right? That is the meaning. That's why I have equated both of them. I hope that was clear. If the trajectory equation is given, what is the maximum height attained by it? Now, whenever you are given some trajectory equation, meaning there will be a graph associated with it, and whenever the height is maximum, wherever the height is maximum, there is one unique thing which happens, and that is the derivative dy by dx will be 0. It is the point of maxima. It is basically the point of maxima. So all you need to do is find the derivative of this. Dy by dx will be derivative of x minus x square by 20. But at the maximum height, this is 0. So derivative of x is 1. And this is nothing but 2x. Shift it on the other side. So x by 10 is equal to 1. So x is basically 10 meters. But that's not the problem. The problem is to find the maximum height. So maximum height will be that y coordinate, which you can get by substituting the value of x as 10. So 10 minus, use this equation, 10 minus 10 square by 20. So I found out the value of x. The value of x came out to be 10 meters. At that x, what is the y? That is what the question is now. So just substitute. 10 square is 100, 100 by 20. 100 by 20 is nothing but 5. So hence the answer is 5 meters. Hence the answer is 5 meters. Is that okay? Understood? Everybody with me on this? Cool. Let's move ahead to the next question coming up on your screen. If there is an object which is thrown from point A and hits the ground after 3 seconds, the line from A to B makes 30 degrees. What is the initial speed of the object? That's the question. Very interesting. So this base is not given, the height of the tower is not given, speed is also not given. In fact, that is what you have to find. Just the angle is given and the time of flight is given. Try to recollect any formula that you know for projectile from a hill. And mainly because time is given that it falls after 3 seconds, is there some formula for time which you know already? Yes, the formula for time is root of 2h by g. In fact, if you put the value of time as 3, I think we will be able to find the height also. G value is 10, 3 square is 9. So this will be 2h by 10, this will become 5. So h will become basically 45 meters. Now that I know that the height is 45 meters, I can also find the base if needed, because I think for initial speed, I will need this base. Because what else will give me the speed horizontally? I need something in the horizontal direction, right? Okay, so what do? We'll use trigonometry over here. We can see that tan of 30, which is height, by base, which is BC. So basically BC will be 45. Tan 30 is 1 by root 3, goes on the top, will make it root 3. Tan 30 is 1 by root 3. So root 3 goes on the top, will make it 45 root 3. So hence the base is basically 45 root 3. Do I know some other formula apart from time? Remember, range from the foot of the hill to the place where it lands is speed into the time. Range, we got it as 45 root 3. Speed, I don't know. Time was already given as 3. So V will be 45 by 3 is 15. So 15 root 3 meters per second. That should be the answer. 15 root 3. Yes, it is the answer. Got it? Everyone with me on this? Right? So this is how you apply the formulas. This is how you think about a problem. Whatever is given, try to think, is there some formula associated with it? Yes, time of flight. Oh, I have to find speed. But to find speed, height is not important. The base is important, because that will give me the range formula, which is u into t. I know time, I don't know range. So to find range, I use trigonometry. So one thing will lead to other. You start from what is given, you go reverse, see what you need for that. You can find that missing link. The missing link was here, right? Cool. A stone is thrown at some angle, reaches the maximum height. What is the time of flight of the stone? What is the formula for time of flight? If you know that, maybe that will help me. It is 2u sine theta divided by g. But speed is not given. Instead, maximum height is given. Maybe we can use something. H is nothing but u square sine square theta by 2g. Take 2g on the top. So 2gh is basically u sine theta, and this is squared. So u sine theta will be basically root of 2gh. So instead of u sine theta, put over here root of 2gh. Rest of the other terms like 2 and g will be common as it is. Root g will cancel. Root g will cancel. It will become 2h by g. Root of 2h by g. So 2 into root of 2h by g, which is option C. Which is option C. How many of you wrote option C? Gaurav, it should come by this week end, I believe. Yeah, it should happen anytime this week. Don't worry about it. You remember, right? Everything comes on time. Just few days before, usually 4 days before, 5 days before, you will get that admit card also. Don't worry. So for now, just concentrate on problem solving. City intimation slip, usually 2 weeks before it should come. That means sometime this week. Right. Moving on to the next question. If there is an aeroplane which is going at this altitude with this speed above the ground towards a point directly over the person struggling in flood water, at what angle of sight with the vertical should the pilot release the survival kit if it has to reach the person in water? This problem is very similar to projectile from a height, or throwing an object, from some tower, or dropping a bomb from the aeroplane. These are all standard questions, if you remember. So let's see what do we need to do in this particular situation. First of all, what you need to do is convert this kilometers per hour into meters per second. So 600 kilometers per hour into basically 5 by 18, right? This is what you will do. So divide by 6, it will become 3. This will become 500. So 500 by 3 meters per second. That is in meters per second. Now let's visualize what exactly is happening. This is the ground level. This is the person who is struggling in water, and there is an aeroplane over here. It has to release some food packet. This is that aeroplane. Okay, this is that aeroplane. It is going like this with a very high speed at a very high altitude, which is 1960 meters. So when it drops a food packet, what will happen? That food packet will take up this trajectory. It has to land over here. So what and all do we need? What and all do we need to find the angle? Do I know the height? Yes, I think if I just know what this distance is, most of my job is done. Because if I know the base, I think I can find the angle. I can find this particular angle, whatever is needed. So this is the direct line of sight. The person who is struggling sees the aeroplane here. That's when the aeroplane releases the food packet and it continues its journey. Only then the food packet will land here. If you leave it before or later on, it will go ahead or fall before, not near him. So that is why drawing this particular triangle becomes very, very crucial. Everybody with me on this? Very good. So with this particular height, which is given to me 1960, the first thing you can find is time of flight. The time of flight is basically root of 2 into height, which is 1960. I think the value of g has to be taken as 9.8 over here, right? So 19.6 is 2 times 9.8. So I can just write it as 2 into 9.8. And this will make it 19.6, 2 more decimals, so 100, and divided by 9.8. 9.8 cancels, so it will become 2 into 10, which is basically 20 seconds. Just check if the time value comes out as 20 seconds. This will be needed for me to find the base of the triangle, which is basically the range. Range is speed into time. Speed is how much? 500 by 3. 500 by 3 into time, which is basically 20 seconds. Into time, which is basically 20 seconds. Is that fine? Everybody with me? Very good. Very good. So what will this happen then? What will you get? 500 into 20 by 3, right? So that will give me 1000 into 10, which is 10,000 divided by 3. Once I get this, the only job that I have is to find this angle, or basically to find this angle. Find the line of sight with the vertical they have asked you. So basically they have asked you this angle theta. So you can basically find this angle theta. So hence tan theta, which is opposite by adjacent, will be 10,000 divided by 3 divided by the height. Height is basically 1960. You can cancel few things. You can see where is tan theta approximately coming out to be. Is it coming out to be root 3 or 1 by root 3 or 1 by root 2? Just check it. If it is coming out close to 1.732, close to 1.7, if it is close to 1.73, that means our theta should be 60 degree. Theta should be basically 60 degree. Okay, everybody cool to this point? Awesome. Great. No, it is not option A. It is not option A. Just check this out. It will be, yeah, it will be option number C. Be careful. Yep. Is that okay, everyone? Shall we go ahead? Great, great. Moving on to the next one. A ship is going to the east with 12. A woman goes 5 meters per second relative to the ship towards the north. What is the speed of the woman relative to the ocean, relative to the sea? Okay. Okay. So what do? First of all, realize this is just like your boat swimmer problem in the river. So the ship steaming due east is this much. The woman running in the deck at this much. So if I talk about the velocity of the woman with respect to the ship, it will be the velocity of the woman minus the velocity of the ship. So therefore, the velocity of the woman will be velocity of the woman with respect to the ship. Take this on the other side, plus velocity of the ship. This is vector addition, remember that. So what is the velocity of the woman with respect to the ship? It is given that she is moving towards the north. So this is 5 j cap. What is the velocity of the ship? Velocity of the ship is 12, basically I cap towards east direction. So this would be the velocity of the woman. But if you ask me what is the speed what is the speed of the woman, you just take the mod of this. So it will be root of 5 square plus 12 square, which will be 13 meters per second. So actual speed is 13 meters per second. But if you look at it direction wise, some components are there. 12 I cap is there and 5 J cap is there. 5 J cap is there and 12 I cap is there. So this is the net velocity of the woman. Net velocity of the woman. She is going at an angle. Yeah, slightly towards the north and towards the east. Yes, very good. Moving ahead to the next question coming up on your screen. A river is going from west to east with 5 meters per minute speed. A man can swim at 10 meters per minute. What direction should the man swim so that he takes the shortest path to go south? He has to take the shortest path to go basically south. Think about it. A man can swim. What direction should he be swimming? So just imagine this to be the width of the river, like this. The river is going this way with a speed of 5. If he has to go along the shortest path, that means he has to go basically like this. He has to swim little bit against the current. So he will be pointing this way. The velocity will be nothing but 10. But the river will pull him over here. Like this. And he will end up going resultant like this. This will be the resultant. Velocity perpendicular to the banks. And that's how he goes in the shortest path. Now, if you actually measure this particular angle over here, let's say I call it theta, you can see sine theta is opposite by hypotenuse, which is half. That means theta is 30 degree. So basically you should make 30 degrees with the south direction. Now if you remember the directions, it will be like this. This is north, this is east, this is west, this is south. So the actual angle that he is making is like this, 30 degree. 30 degrees with the south towards the west, 30 degrees towards the west, right? So basically, I think over here, man can swim in still water. Which person should it so as to take the shortest path to go to the south? I think it should be 30 degrees west of south, not east of south. I think over here, this should have been west. Yeah, everything else is fine. Yep. Is that clear? Everybody with me? Yep, very good. Yep. Yeah, it should have been west of south. You can see he has to swim slightly like this. It is going from west to east, the river. So he has to swim slightly against the current that way. Cool? Shall we proceed ahead to the next one? Awesome. Moving ahead to the next question. A man is sitting inside the bus and he is traveling in the direction from west to east, speed this much. He observes the rain to fall down. That means it is an apparent motion, relative motion. So the person who is standing on the ground, how will the actual direction of the rain move? Is the question. So let's use our beautiful equation which says velocity of the rain with respect to the man is nothing but the velocity of the rain minus the velocity of the man. This is the actual equation that you need to use. The velocity of the rain relative to the man is vertically down. So that means VRM vector has to be like this. This is your VRM vector. The person is going from west to east. That means the velocity of the man is like this. But you don't need Vm, you need minus Vm. So think of only this vector. Minus Vm will be exactly opposite of it. So let's say I put minus Vm vector like this. You'll be like, sir, why did you put it here? Why did you not put it here? I'll tell you also why. Because there is one more vector which I need to add. VR vector plus the negative of Vm vector. So only then I'll get VRM vector. So technically speaking, this will be VR vector. So VR plus this negative Vm gives you this vector. Triangle law. A vector plus B vector is C vector. So this is how the rain should be falling. And remember, this was the west side and this was the east side. So how was the rain falling? How is the rain falling? It's falling down but slightly towards the east side. So guys, it is falling at an angle going from west to east. It is falling at an angle going from west side to the east side. Yes, the correct answer is option B. Very good if you guys got it till here. Study UP, if you're in first year, you should be able to still solve all these questions, let me tell you, if you are done with the syllabus. So this will be a good revision for you if you are in the 11th moving 12th standard batch. Yes, Sanjay, that is correct. Cool. Shall we move ahead? Why don't you take the velocity of the man in the right direction? In the previous question, you mean this one? This one, why did I not take? I in fact have taken it in the right direction, but why did I make left direction? Because of this. What is vector subtraction? It is nothing but adding a negative vector. So although he was going from west to east, when I have to use this equation, I have to choose always minus Vm. See, what is the problem with these problems is that many people remember formula. But if you have seen my actual old classes, Nurture, Pathfinder or any classes, I never teach using some formula. The only thing you need is this and vector subtraction. You should realize that minus Vm means I have to make the velocity opposite direction. And then I have to add it. So treat it like a new vector only altogether. So this is a vector, this is only b vector. So a plus b gives me c. So you have to align these vectors so that the resultant is down. That because that is the net resultant vector of this and this. Is that okay? Yeah. I hope this is clear. Cool. Shall we move ahead to the next question coming up on your screen? Here it is. A fireman wants to slide down a rope. The rope can hold only 3/4 of the total weight of the person. What is the minimum acceleration of the fireman to slide down? That is the question. So let's draw the diagram, only then we'll get an idea. This is that rope. Okay, let's say this is that fireman like this. He's holding on to the rope like that. Now, what are the different forces acting on him? The rope will be pulling him, applying some tension. He will be pulling the rope, same tension, equal opposite by third law, but acting on different bodies. We are drawing Pandu, the fireman. The weight of the person will be there. And obviously, the acceleration will be there as well. The acceleration will be there as well. These are the only forces acting on the person, nothing else. So from this, weight minus tension is basically mass of the person into acceleration. It is clearly mentioned that by the way, weight is mg. The tension which he can bear is 3/4 of the weight of the man. So this is basically 3/4 of mg. That's it. So this is equal to ma. mm cancels. So g minus 3g by 4 is equal to a. So a will be g by 4. So g by 4, where is it? Option D for IIT Delhi. Yes, that is the correct answer. Cool, clear. Shall we move ahead to the next one coming up on your screen? Ready for it? Very good. Yes, let's move on. Guys, concentrate on the class. Don't focus on chatting with each other. Concentrate. Exam is just 2 weeks away, JEE Mains. Other exams, VEDANTU JEE English, EMSAT are just 1 month away. So make sure you're utilizing the lecture to the best, right? So moving on to the next one, coming up on your screen. The system over here shows that the acceleration of the 1 kg mass and the tension, how much it is. Okay, so 3 kg, 1 kg, 3 kg over here. Question is, what is acceleration and what is the tension between block A and block B? Simple way, I'll tell you, simple formula. On this side, the total mass is 4 kg. On this side, the total mass is 3 kg. Acceleration is always the bigger mass minus the smaller mass upon the total mass, the whole thing into g. This is the basic formula. If you remember this, your job will become very easy. What is the bigger mass? 4. Smaller mass 3. Total mass 4 plus 3 into basically g over here. So this will become basically g by 7. G by 7 is only there in option C. Will you check whether the tension is 6g by 17? I don't think so. Directly you will mark option C. You will not even check in the exam. But let's say this was also g by 7, this is also g by 7. Then you have no other choice but to check it. And how do I check that? What is the tension between A and, what is it? A and B, right? So what is the free body diagram of A going to look like? There will be one tension, there will be one G, and there will be acceleration. How much will that acceleration be? G by 7. G by 7. Write Newton's equation. This minus this is total mass into acceleration. So 1G minus tension is basically mass into acceleration. Mass into acceleration. This is just net force is MA, Newton's law. So that's it. Tension will be equal to G plus, tension will be equal to G minus G by 7, which is 6G by 7. That's your tension, which is there over here. It's just double checking it or cross checking it. That is the correct answer. Moving to the next question. Here it comes. Question on constrained motion. Many people get confused in these questions. You are pulling this string, it is passing over the pulley, it is attached to this mass. If you pull this with V, what is the velocity of the block? Think like this. If you are pulling this with velocity V, even the string over here is coming with V. Whatever you give only will go there. So basically the string is going up with velocity V. But the actual velocity of the block is over here. The actual velocity of the block U is actually over here, of which V is a component. Here many people fail to understand who is a component of whom. Many people think V is the actual velocity and U is the component of it. No, the block is actually moving here. So where is it actually going becomes the resultant. Where is it actually going is the resultant of the velocity. So this V then becomes, this V basically then becomes the component. This velocity becomes the component. In fact, this has two components. This U has two components, one here and one here. Okay, if you see it that way, it makes sense. So if this is theta, obviously this is theta. So therefore, can I not say V is nothing but U's sine theta component? V is nothing but U's sine theta component. That is the answer. So the velocity of the block is basically V by sine theta. That is what was the question. U was nothing but V by sine theta, which is exactly what was predicted. Cool, got it? Who has to be taken, whose component, right?
Something went wrong. Please try again.
Oops. Okay. Am I audible, guys? Am I audible? Just one second. What is my phone saying? Yeah. All right. Okay, cool. Let's move ahead to the next one. This diagram shows 2 kg wedge. On that there is 1 kg mass. There is an angle given also. Question is, if the wedge is given some acceleration, then will it remain stationary? What is the force, net force, etc.? That is the question. Very nice question, let me tell you. So, in fact, let me create a duplicate of this. I have to start by drawing the free body diagram, and because I am accelerating the wedge with 2 meters per second square, let me choose this as my frame of reference, which is going to be now non-inertial frame, because it is accelerating, and it is accelerating with how much? 5 meters per second square. Because of this only, the pseudo force will come. The pseudo force will be exactly opposite to the acceleration. The pseudo force will be mass into acceleration. Mass is 1, acceleration is 5, so it is basically 5 Newton. This pseudo force will have components, one component here, another component here. By the way, this will be 5, this is 37, this is also going to be 37, this is 37, this is 37, so this is 5 cos 37, this will be 5 sin 37. Apart from that, the actual normal force will be there, the gravity will be there, whose components will be like this and like this. This component will be 1g sin 37, mg sin theta. This will be mg cos theta. M is basically 1, G is G, and this is cos 37. This is what it is. So you can see normal force is 1g cos 37, 1g cos 37, and this is also there. Check this out, 5 plus 5 sine 37. Just check this out, plus 5 sine 37. So what is cos of 37? Cos of 37, how do I find it very quickly? Remember this triangle. I have told you about this particular triangle. 3, 4, 5. 5, 3 will make this 53. 5, 3 will make this 53. This angle will be 37. This angle will be 37, guys. Yes. So cos 37 will be 4 by 5. Cos 37 will be nothing but 4 by 5 plus 5 into sine 37 is nothing but 3 by 5. 3 by 5. G value, if you want, you can put it as 10. G value, you can put it as 10. 5 goes with 10 2 times, so it will become 8 plus 3, which is basically 11. So the normal force is 11. I can see it is there as B option. I won't even check other options because I have got this as the answer. Automatically others will have to be wrong. It's a single correct one. It's a single correct one. There is no doubt about it. Cool? Make sense? Right. Moving ahead over here, if you want to find what is the acceleration of the block and all of that, here I don't think these two forces will be equal. Maybe we can find it out. 5 cos 37. Cos 37 is 4 by 5. So 5 into 4 by 5 will make it 4 Newton. 1g sine 37 will make it 10 into 3 by 5. So which will make it 6 Newton. 6 is acting down, 4 is acting on the top. Net force will be down, because of which you will see that it will have some acceleration down. So therefore I can say 6 minus 4 is mass into acceleration. So 2 is equal to A. So the acceleration is 2 meters per second square. This is saying 1 meters per second square, which is wrong. It should actually be 2 meters per second square. 2 meters per second square. That is also wrong. Is that clear? Everybody with me? Great. Moving ahead to the next question coming up on your screen. If the coefficient of friction is given between the insect and a bowl, what is the maximum height till which the insect can crawl? This kind of question has come many times in the actual JEE exam. You would have seen this. What is the maximum height? Sometimes values are given. How will the diagram look like? This is the bowl. This is the bowl. This is the ground level, let's say. This is the ground level. What happens is, as the insect goes up, let's say over here, inclination will increase. Inclination will increase and the tendency to slip will increase. So think of the tangent to this bowl as an inclined plane, and there is a maximum angle till which a block can be kept at rest on an inclined plane supported by friction. That angle is called angle of repose. If you recollect, angle of repose is the maximum inclination before which the block begins to slide. So what I will do is, I'll just draw a particular tangent over here. This is the maximum angle which it can make. Let's say I call it alpha, right? I call it alpha. And let me draw the other things which are important over here, like the radius, over here and all of that. And let me also draw the horizontal. Let me also draw the horizontal over here. And the question that is being asked is only this. What is this height? What is this height? So if this angle is alpha, no doubt about it, this angle will also be alpha. You will be like, sir, how did you get it so quickly? I know that if the tangent rotates by alpha, even this point with respect to this point would have rotated by alpha. Think, when the tangent was horizontal, the radius was like this. The tangent rotated by alpha, even the radius would have rotated by alpha with the vertical. Or else you can just start marking this point. This will be also alpha. This will be 90 minus alpha, and so on and so forth. Either that or through proper visualization. Either ways you will get the same answer. Now once I know this is alpha, then what can I do? I know this particular height. I know this particular height because this is radius. This will be r cos of alpha. This will be r cos of alpha. So what will this height be? What will this height be? Because the total height is from here to here is r. So it will be r minus r cos alpha. R minus r cos alpha. R minus r cos alpha. I take it as common. So 1 minus cos alpha. Okay. So the real question now is, what is cos of alpha? I know that this alpha is your angle of repose. Angle of repose. And what is the formula for angle of repose? Tan alpha is basically mu. Tan alpha is basically mu. Meaning, if you think of a triangle having this angle as alpha, tan, which is opposite by adjacent, is mu. So this hypotenuse will be 1 plus mu square. This hypotenuse will be 1 plus mu square. So cos of alpha, adjacent by hypotenuse, adjacent by hypotenuse, that is the answer. So height will be r common, 1 minus 1 by 1 plus root, 1 plus mu square under the root. Yes, that is the correct answer. Got it, everybody? Shall we proceed ahead to the next question? Yes, very good, Gauravji. Beautiful question which involves little bit of trigonometry. The concept of angle of repose is also there, and yes, you have to use proper algebra and geometry, otherwise you can make some silly mistake over here. The next question, block on block questions are also very famous, where you have been asked what is the minimum force to just begin the motion, or what's the maximum force so that they don't slide. Those kind of questions are also very common. Now these two blocks are kept over each other. The bottom surface is smooth. Friction only exists between the two surfaces of the block. You are pulling it by 15 Newton. So you don't even know whether the frictional force is static or kinetic, because nothing has been mentioned whether the blocks are sliding or moving together or just about to slide with respect to each other. Nothing has been given. But one thing is there. If I consider them as a whole system, if I consider them as a complete system, then they will have some acceleration, and I can say net force is equal to the total mass into total acceleration. So total force is 15, mass is 6 into acceleration. So acceleration will be divided by 3, it will become 5 by 2 meters per second square. That's the total acceleration if they are moving as a system together. Now just consider the 2 kg block. Just consider the 2 kg block and see what are the different forces acting on it. Obviously one is 2g force down, another is normal force, and it will be having this acceleration, and it will also have some friction. It will also have some friction. So no other force apart from this. I am looking at it from the ground frame, so I am seeing it go with with some acceleration of 5 by 2 meters per second square. So here I can say F is equal to mass into acceleration. That friction I don't know. Mass is how much? 2. Acceleration is 5 by 2, which makes it 5 Newton. This is the friction which is actually there between 2 and 4 kg. But you cannot be so confident unless you check whether it is more or less than the static friction. So just check what is Fs max, which is nothing but mu into n. Mu is 0.3. Normal force will be 2g. So 10 into 0.3 will make it 3. 3 2s are 6 Newton. So 5 Newton is less than 6 Newton. That means this friction will be static in nature and they are moving together. Maximum friction is 6 Newton, but that much is not needed now. You just need 5 Newton. If this value comes out to be 7 Newton, that means they are not moving together. That means you have already overcome the static friction. It has gone into the kinetic zone. And kinetic friction will also be mu n, and you will see 6 Newton of kinetic friction will be there between the blocks. They will have relative motion between them. Right now, there is no relative motion. Right now, there is no relative motion. Keep that in mind. Next question. 2 blocks are connected by a metal rod, 8 kg. The system is pulled up by this much Newton. Tension at the midpoint is asked. Tension at the midpoint is asked. So, you know what you can do to find the tension at the midpoint? Divide the system into 2 parts and think they are connected by some force like this. Imagine this now. The upper mass M1 is how much? 20 kg. The whole rod is of 8 kg. So can I say this is 4 kg, this is 4 kg, and M1 is how much? 20 kg, and M2 is how much? 12 kg. So it's as if you have a mass of 20 plus 4, which is 24 kg, 4 plus 12, which is basically 16 kg, and they both are connected by a force. They both are basically connected by a force, so there is tension over here, and that is exactly what has been asked. What is the tension at the midpoint? So what do you do now, my dear students? Think to find the tension at this particular midpoint. You have to just draw the free body diagram. Either of this or of this, it's completely up to you. If you take the free body diagram of that particular 6 kg mass, the forces acting on it are tension and its own weight, which is basically 6g. And apart from that, there will be some acceleration also. Can we find the acceleration? Why not? Why not? I know if I take the whole thing as a system, 480 minus the total weight, which is 20 plus 8 plus 12g is the total mass into acceleration. Which is 20 plus 8 plus 12 into acceleration. Does that make sense to all of you? The total force will be 480 minus the weight. That force will be the total mass into acceleration. That's all I have written. From this, you can find out the value of acceleration, my dear warriors. Have you understood it till this point? Just let me know quickly. So what will this be? 480 minus 12 plus 8, 20, 20 plus 20, 40. So this will be 40, and into g, that means 400 is equal to 40 into a. This will be 80. So a will be basically 2 meters per second square. Once I get this acceleration, use this over here like this. Tension minus 6g is equal to mass into acceleration. So tension will be equal to 6g, means 6 into 10 plus 6 2s are 12. 60 plus 12, that's 72 Newton. So 72 Newton, I think something is wrong. Oh, I wrote 6g, my bad, it was 16g, not 6. I wrote it as 6g, so sorry. This was not 6, it was 16. This was 16, yeah. So this would be actually T minus 16g is equal to 16a. And that a value I know is nothing but 2. So from this, you will write 16g plus 16 multiplied by 2, 16 common, g is 10, 10 plus 2 is 12, 16 into 12, which is going to be 192 Newton. Yeah, just check this out. 16 into 12, that's 192 Newton. Is that okay, everyone? Very good. Awesome. So what is the crux of this problem is not Newton's law equation F is ma, but the choice of system. Because the force was asked here, if I take the entire thing as a system, this tension becomes internal. So when I choose the entire system, I was able to find the total acceleration, which I found over here. To find the tension, I separated them out into two different bodies. I either draw this guy or this guy's FBD, and then I write again the free body diagram and the Newton's equation. F is equal to ma. Solving that, I get the tension. So whenever you have to find the force somewhere in between, make sure that the force is external by the right choice of the system. Okay, I hope this is clear. Nitish, in the previous question, why are we taking height? Which height? This one? Because that is what was the question. The maximum height was asked. See this? The maximum height to which the insect can crawl. So this is the height, right? Maximum height till which the insect can crawl is what is asked. That is the reason. Because it was asked. Okay. Moving ahead. Beautiful question again. 2 people are pulling P and Q points of threads like this mass will go up. It is making theta equal angles. The situation is completely symmetric. With what speed does this mass go up? If you are pulling P and Q points down with a speed of u, you are pulling it down like this with a speed of u, like this, with a speed of u. With what speed will this guy go up? That is the question. That is the question. What will you do is either visualize or use my technique of net work done by tension is going to be 0. That will be a better technique to do over here. See, at this particular point, if you notice, there is, for example, tension T over here and tension T over here. Then downwards at this particular point, the tension acting is 2T cos theta. Why? Because T cos theta will act up. So total tension up will be 2T cos theta, which has to be balanced by downward tension of 2T cos theta. Is that making sense? Very good. That is at that particular point. So using the concept that for a light inextensible thread, the net work done by the tension forces is going to be 0. Net work done by the tension forces is 0. Work done by the tension over here, because the same string continues here, will be, let's say T into basically x. Same thing over here, it will be plus T into x, because the same string continues tension into displacement. Here, this string is connected to this guy. And the tension acting, let's say, over here, if I call it as 2T cos theta, so let's say this is 2T cos theta, the displacement is y and the total sum should be 0. 2T cos theta is the tension and displacement, let's say I call it y. So force into displacement is the work done. But be careful about the signs at all these places. Like for example, for this particular mass, right? For this particular mass, the tension acting on it will be like this. The displacement is also like this. Tension and displacement are in the same direction. But for this particular point over here, right? For this particular point P over here, realize the tension is here, the displacement x is down. So actually work done will be negative. So technically speaking, both these are negative works and this is basically positive work. This is negative work, this is positive work. So what will you get as the final answer? You will get minus 2xt is equal to, or rather minus 2xt plus 2t cos theta y is equal to 0. T cancels, bring this on the other side, even cancel 2. You will get 2 has also gone, my bad. Just y cos theta is equal to x. Now divide this with time, divide this also with time. Y by t, displacement by time is velocity. So that will give me velocity of the mass into cos theta is equal to x by t, displacement by time will give me displacement of point P, velocity of point P, which is basically u. So therefore V will be nothing but u by cos theta. V will be nothing but u by cos theta, which is option number C. So the technique which I have used is the total work done by the tension at all the endpoints will be 0, because the string cannot store energy. And work done is force into displacement. If this string had tension T, this has tension T, this string will have some different tension, because net force has to be 0. So tension cos theta, 2T cos theta balanced by 2T cos theta. So this element has 2T cos theta. Work done on this mass will be nothing but this 2T cos theta into y, that is positive. On this guy, tension is up, displacement is down, so negative work, force into displacement. So solve it, you will get the relationship between their displacements. Divide with time, you will get velocity. If you divide with time again, you will get acceleration. That's how I did it. Is this concept clear, how we did it? Is this clear, everyone? Cool. I only studied 99 percentile series. It is not included in that. Which 99 percentile? Have you watched my old classes as well. I hope you have Pathfinder Nurture series, how to solve the questions on, constrained motion. It's all there on this channel, right? So make sure you're utilizing all these resources which are freely available, the theory which has been taught to you. Next question: particle of certain mass has been subjected to certain force and it moves as per this particular graph, and this is force versus x graph. Question is, what is the velocity at x is equal to 12? At x is equal to 12. Hello Jaya Durga, good afternoon. All right, yes, we will be doing. Yes, Uchuk, they were gems. Force displacement, not force time. What does force displacement graph give you? I think the area gives you something, not the slope. If you calculate the area, that will give you the work done. Okay, the area basically gives you the work done, and that work done comes out to be half into height, which is basically 10, into sum of parallel sides. This side is 8 minus 4, which is 4, plus 12, correct? 4 plus 12, 16. 16 by 2, 8. So this will become basically 80 joules. As per the work kinetic energy theorem, this work will be the gain in the kinetic energy, or the change in the kinetic energy, which in this case is half into mass, which is 0.1, into V, which I do not know. Initially it was at rest. It starts from rest. It is clearly mentioned over here. That's why final minus initial, which is 0. Okay, so basically 80 is equal to half into 0.1 into V square. Bring that 2 on the top, bring that 0.1 here, it will become 1600 is V square. So V is basically 40. V is basically 40, which is option B. Yes, that is the correct answer. Cool. So this was a question on area under force displacement gives you work, and from that you find the kinetic energy and then the speed. If by chance this was time, then understand the area under this will not give you work, it will give you the change of momentum. Force time area gives you change of momentum or impulse. Okay, so that's how you would have solved the question. So we have come already to work, power, energy and all that. If there is a mass, there is this force, how much work is done to move the object from 0 to 5 coordinate? Whenever force is given as a function of x, to find the work you just integrate it using this formula. Work is basically integration of force into displacement. If this is force due to only x component, this will be also x component or x displacement only. So what is that force? It is basically 3 plus 2x, and this is into dx. So 3 integral dx is basically x, 2 x dx's integration is basically x square by 2, but you have to put the limits also. Do not forget that you have to put the limits also. 0, 5, 0, 5. So this will become 3 into 5 minus 0 plus 2 cancels. It will become 5 square minus 0 square. So this will be 15 and this will be 25, which will make it 40. So answer is option B. Yes, 40 joules. 40 joules is the answer. How many of you got it? Very good, Gaurav. Excellente. Awesomeness. Let's continue. Very good, and I hope you guys have liked the video already, and if you have not, or if you have forgotten, just a friendly reminder, please do it right now. Show your support. You are watching all these classes for free, you want to gain knowledge, but you don't want to smash the like button. Come on. A block of mass 10 kg moves up with this speed. It reaches the top and comes back to the same position and stops. What is the work done by the friction in the whole process? This is a brilliant question. If somebody can solve this within 5 to 10 seconds, I would be really proud. I'm waiting to see all your answers. Come on. How many of you can solve it within 10 seconds? Let me just get my water. Naga saying option D. Mayur saying option B. Work by friction. Guys, a lot of you might be thinking it is 0, but 0 is not there as the option. It is going up, going up, going up, and it is also again going to come down. In this entire process, what is the change of the gravitational potential energy, guys? It went and came back, so 0. Gravity wise there was no change, but kinetic wise there was a change. Kinetic energy there was a change, half into mass, which is 10, into V, which is 20, and this 0. Actually, final is 0, initial was this much. So it is 0 minus half into 10 into 20 square. 20 square, 400. 400 by 2, 200. 200 into 10, 2000. So the change is minus 2000. Now think about it. Potential energy did not change. Kinetic energy changed. In fact, it decreased. So where did the decrease of kinetic energy go? So kinetic energy has gone down. Where did it go? Obviously, the work done by friction has sucked it away. So the work done by the friction has come by the loss of the kinetic energy. Potential energy did not change. So it should be minus 2000 joules. Directly I can say option D. Many of you wrote B, but some of you also said C also, but no, it is D. No, work done by friction is not 0. Friction is a non-conservative force. Please remember that. Friction, where is it? Friction is non-conservative. And for non-conservative forces, the work done in a closed path is not 0. So the total work done in a closed path is not 0. So even if you go and come back, even if the displacement is 0, work done is not 0. If it was gravity, spring, electric, elastic, which are all conservative forces, for them the answer would have been 0. Got it? Understood the catch in this problem? Let's move ahead. A block is released from some height. The maximum compression in the spring is how much? That is the question. If you release the block from this height, right, and it is going like this, it's a smooth surface, the entire energy of potential will convert into kinetic, and that kinetic will convert into spring. So the transition happens like this. There is gravitational potential energy that completely converts into kinetic energy, that again completely converts into spring potential energy. So why not equate these two rather than these two first and then these two later on? Gravitational potential energy is mgh, spring is half k x square. So x square will be 2 mgh by k. So x will be root of 2 mgh divided by k. Root of 2 mgh divided by k, which is option number A. Got it, my dear students? Exactly. So you don't have to equate these two and these two. Oh sir, what is the speed here? Then from speed I will find compression. No, I know this goes into this goes into this. Directly equate these two. mgh is half kx square. You can solve for x. Very beautiful question. There is a a track which has some part smooth, some part which is having some friction. The flat part is 3 meters. The curved portions are smooth. Only the flat part has a friction of 0.2 coefficient. If you release this mass from this particular location A, 1.5 meters, where will it stop? Okay. You know what I do to solve this problem? I'll imagine it like this. When I release it, it comes here, all the energy of potential gets converted into kinetic. Now that kinetic energy will be slowly sucked away by the friction. Because even if it goes here, it will go up, stop and come back. But it will come back with the same speed. Here is where it loses that kinetic energy. So how much precise kinetic energy it has? How much kinetic energy does it have? The same amount of potential energy does it have. So which is mgh. Mass is how much? I think it is not even given or something. It's not needed, I guess. Okay, m into g, which is 10, into basically h, which is 1.5. So it is basically 15 m. Now this kinetic energy slowly goes away against the friction. this kinetic energy slowly will go against the work done against the friction. And the work done by the friction is the frictional force into the displacement. Frictional force is mu mg and displacement is s. Mu is basically 0.2. Mass I don't know. G 10. Displacement also I don't know. 10 into 0.2 is 2. So 2 ms is the work done by the friction, or the energy which is going to be sucked out by the friction, and this will be equal to also 15 m. Cancels, cancels. So from this I'll get s is 15 by 2, which is 7.5. The total distance traveled on the flat track is 7.5. Now you know what to do next. The flat track which is having the friction is nothing but how much in length? It is given 3 meters. So first time when it comes, it will go 3 meters like this, and it will still not lose all the energy, because totally it has to travel 7.5 meters. Next time it will travel like this, nothing will happen. Remember, it has come from here, gone like this, it will go up and it will again come down by the same amount. It will again come down by the same amount. Then again over here it will go for some amount up, and again it will come down by the same amount, and now again it has covered 3 meters, total 6 meters, only 1.5 meters is left worth of travel. So it will travel only for 1.5 meter and finally it will stop. So it will stop exactly in the middle. The distance BE will be 1.5. So 1.5 into 2 will make it 3. So the answer is 3. Answer is 3, because the question is 2 times the answer is how much? Got it? Everyone? Very good. Yeah. Moving ahead to the next question. If there is a uniform chain of 3 meters in length, mass something, it is hanging with 2 meters lying on the table, the kinetic energy of the chain when it completely slips off the table is how much? Let's try to visualize this first. Two situations. This is the table before, this is the table afterwards. First, 2 meters was lying on the table, that means most of it was on the table, only a part of it is hanging below like this. Later on, the entire thing is like this. The entire thing is like this. So if I assume this to be mass m, this will be mass of 2m, this will be mass of 2m, this total chain will have a mass of 3m, correct? Understood? Everybody, oh, actually the mass is given also, and the mass is given to be how much? 3 kg. So this is basically 3 kg. So only 1 meter is hanging, means 1 kg was hanging here and the remaining 2 kg was over here. Perfect. Now that I know it was at rest over here, but at this situation it has some speed. Where did it get that kinetic energy from? How did it get kinetic energy? Think about it. Because it has lost potential energy. How, sir? Okay, let's do one thing. Where is the center of mass for this particular rod or chain? Every time this kind of question comes, this has to be solved by a center of mass. The center of mass is here. In fact, the length of the chain is how much? 3 meters. The length of the chain is 3 meters. So technically, the center of mass is 1.5 meters below the table point. 1.5 meters below the table point. For here, most of the rod or the chain is on the table. Only this part is hanging. So that guy's center of mass only you consider. This 1 kg center of mass. This is 1 meter. This is 1 meter. So technically the center of mass is only 0.5 meters below the table. It's just 0.5 meters below the table. That too only for the 1 kg mass. So if I have to write an equation saying like this, initial potential plus initial kinetic is final potential energy plus final kinetic. If I take this level as 0 level, this level as 0 level of potential energy, this part of the mass has no energy because it is on the reference line. You can choose anything as the reference. This part is below the reference. So instead of plus mgh, you will use minus mgh. So the initial energy is only of this part, that too negative because it is below. So it will be minus mass, which is 1, g, which is 10, into h, which is basically 0.5. Kinetic energy is basically 0 because it was at rest. Finally, the entire mass is 3, g is 10, height is 1.5 but negative. Why negative? Because it is below the 0 reference line. Plus half into mass, which is 3, into v square. That's it. Solving this, you will get the answer. Everybody with me? Understood? Clear? What we had to do? The main concept is about center of mass. Only the mass which is hanging, consider that part as the mass and find the center of mass of only that part. Reference level, take it as a table. Accordingly, all the masses which are below will have negative potential energy. Now you have to just solve this. So this will be nothing but 5 with negative sign. This will be 3 into 1.5 or 1.5 decimal will go. 15 3s are nothing but 45. And this will be nothing but 3 by 2 v square. So take it on the other side. This will become 40 is equal to 3 by 2 v square. This will become 80 by 3 is equal to v square. So v will be basically root of 80 by 3. V is equal to root of 80 by 3, right? That is what you will get. But I think here they had asked what is the kinetic energy, not the speed. So if you look at this quantity over here, if you just look at this particular quantity over here, this is basically your kinetic energy. This is basically your kinetic energy. So the value of the kinetic energy comes out to be 40 joules. The value of the kinetic energy, if K is the value of the kinetic energy, that just comes out to be 40 joules. Speed, if it was asked, it would be root of 80 by 3. Right? Moving ahead, shall we go ahead to the next question, guys? Here it comes. A body of certain mass accelerates uniformly from rest to v1 in time t1. The instantaneous power to the body as a function of time is how much? It's going from rest to certain speed in time t1. Let's visualize. It's starting from rest, goes to this velocity v1 in time t1. Definitely there was some acceleration. In fact, that v1 I can say is u plus acceleration into time. Therefore, acceleration was v1 by t1. Now, the question is, what is the power as a function of time? So, at any random instant, you take any random instant when it has certain velocity, that velocity will be u plus a into that time. Acceleration is v1 by t1 and time is basically t. This is velocity at any instant. I will need it because I want to find the power. I want to find the power. And what is the formula for power? Power is force into velocity. Force is mass into acceleration. Mass is m only. Acceleration is v1 by t1. Velocity is v1 by t1 into t. So this will become m into v1 by t1 whole square and this into t. So v1 by t1 whole square into t, that is option number B. Yes, that is the correct answer. That is the correct answer. Shall we go ahead? No, it is not D, my dear students. I think you missed that T. You missed that one T, 1 square. So be careful. T1 is there here also. T1 is there here also. It will make it T1 square below denominator. Beautiful question on power. Power is force into velocity. That is the formula which we need to use. Next question. Two blocks are there connected by a spring. If both are given some speeds, what is the maximum elongation of the spring? That is the question. What is the maximum elongation of the spring? Okay. So if you give both these blocks certain velocity, what will happen? The spring will start elongating, and finally when they stop, all the kinetic energy, because both of them had kinetic energies, will get converted into the spring potential energy. Why 2? Because there are two blocks. What is the kinetic energy? Half mv square. And spring energy is half k x square. Question is find the elongation. Okay. 2 cancels. Mass is given as 250 grams. 250 grams means 0.25 kg into speed. Is it given? No. It's just v is equal to half spring constant, it is given as 2 into x square. 2 cancels. So basically 0.25 is 1 by 4. V is nothing but x square. So x will be V, this was V square, V by 2. X is nothing but V by 2, which is, yeah, B option. B for IIT Bombay. Just check this out. No, it is not D. B option. Yeah. Cool. So this 2 is very important. Many people miss this 2. They just write kinetic energy got converted into potential, but both the blocks had some speed. Both the blocks had some speed. So 2 into kinetic energy is converting into spring, because once they get fully extended, they would have stopped. Keep that in mind. Next one. Conical pendulum based question. Length is L. It is fixed at one end. It is carrying some mass. The string makes 2 by pi revolutions per second. Then question is, find the tension in the string. This is a direct formula based question. Tension formula is m omega square L for a conical pendulum. The only question is, what is omega? Remember that your omega is nothing but 2 pi f. Right? It is nothing but 2 pi f, and it is given that it is making 2 by pi revolutions per second. So frequency itself is 2 by pi. Pi cancels, so omega will become 4. So you just put the number 4 over here. You have to square it and L. So this will become 16 ml. 16 ml should be the answer, which is D option. Yes, it is correct. Omega is 2 pi f. It's already given. It makes 2 by pi revolutions per second. You will get omega is 4. Substitute here, you will get the answer. Right? Shall we move ahead to the next question, guys? Ready for it? Very good. Karthik, you don't know this formula? I'll tell you where to find it. How many of you have seen my formula revision class? How many of you have seen entire formula revision class? I had taken this. I had taken a lot of effort. Just do one thing. Just search for physics formula on the channel. Just search over here. You will see. Will you see this lecture? Complete physics formula revision JEE Mains 2024. Click on this new syllabus based. In that I have given a cheat sheet of all the formulas. Okay. And I don't know how many of you know this special gift which I had given in this session. Wait a minute. Yeah, this is a big session, almost 7-hour class. The biggest advantage of this class is not just the video, but also this PDF which I have given. It's a cheat sheet. Click on this link, enter your details. You will be able to download it for free of cost. Okay. So use this complete PDF of the formula sheet. Got it? Understood? Clear? Loved the surprise? Loved the gift? I hope you now will download it. Yeah, I'll be taking it as a YT class. Correct. Yes, Sri Sarkar. Definitely. Cool. Moving ahead to the next question. A frictionless banked track has a curve of radius this much. The speed of the car is this much. What should be the banking angle? The formula that you need to use is optimum speed formula is root of Rg tan theta. Optimum speed formula is root Rg tan theta. The optimum speed is 90 root 3 and radius is what is it? Oh, sorry, the speed is, my bad, speed is not 90 root 3, the speed is 30. Radius is 90 root 3. G is basically 10, and what else is there? Angle is what I do not know. So square both sides. This will become basically 900 is 900 root 3 tan theta, because 10 into 90 is 900. 900 will cancel. Root 3 you bring it down over here. That will be tan theta. Naturally, theta will be how much? 30 degree. Theta will be basically 30 degree. What is the banking angle? Why have they put 60 degree? Oh, there is a misprint over here. If you look at the solution, they have put 90 by root 3. So over here, I think one slash was missing. Maybe that's the reason why the answer given over there is 60 degree. But if it is 90 root 3, answer is 30. There is a slash missing. Then what will happen? That root 3 will go on the top. That means theta will become 60 degree. Cool? Is that fine? Right. Let's move ahead to the next one. A block of mass at the end of the string is whirled in a, oh my god, already the answer is seen. A block of mass is whirled in a circular path, vertical circle of radius r, the square of the critical speed at the top, so that the string would slacken before the block reaches the bottom. Okay, think about it. The critical speed, when you are in a vertical circle and you are at the topmost position, there is a critical speed for which the tension roughly becomes 0. It almost becomes, slack. Almost just is on the verge of becoming slack. That critical speed is root Rg, if you remember. So if you square that critical speed, it will become just Rg. In fact, at the bottom, the speed is root 5 Rg, root of 5 Rg, right? And when it goes on the top, slowly the speed reduces, and finally it becomes root Rg, right? At the bottom it is root 5 Rg, at the top it is root Rg. Many students end up writing the answer as option A, which is wrong. Okay, clearo? Shall we go ahead? Here it comes. Next question. If there is a body at rest and it starts sliding on a frictionless track from some height, if it is able to complete the vertical circle of diameter d, the height h is how many times the diameter? It's again based on the previous concept that you need to give it certain speed so that it is able to complete the vertical circle. In fact, it so happens that the speed at the bottom, should be root of 5 Rg for it to complete the track. Now, remember, radius is nothing but diameter by 2. So that is the minimum speed required at the bottom. Where will this speed come from? It comes from the potential energy. So I can say the potential energy gets converted into kinetic. So potential is mgh, kinetic is half mv square. So it will be 5dg by 2's root square, the root vanishes, mm cancels, even gg cancels. So h will be m into 5, m has cancelled out, 5 into 2, and this d is also there and this 2 is also there. So this will become 5 by 4 d. So height is 5 by 4 d, which is the fourth option, D option, right over there. Yes, very good, Nitish Sanjay. Yes, it is not B, Sindhu. Be little careful, Nitish. It is not B. It is option D. How to derive optimum speed formula? You have to use the free body diagram, only then you get it. Basically over here the tension is 0, there is mg, and circular motion means centripetal acceleration. So mg will be equal to mass into centripetal acceleration. Tension is 0, so no tension calculation. Mm cancels, so g will be AC. Centripetal acceleration is v square by r, so therefore v square is rg. This is how you get it, using Newton's laws, diagram, circular motion concept. Cool. Let's move to the next one. Two small particles equal mass start moving in the opposite directions. Their speeds are v and 2v. As shown, between the collisions the particles move with constant speed. After making how many elastic collisions at that other than A will these people come back to point A? I'll explain this question. These two start from here with different speeds. They will collide somewhere here maybe. Then they will exchange their velocities. Maybe they will collide somewhere here. Maybe then again they will collide here. Maybe again they will collide here. Maybe collide here. And then finally again collide here. Eventually come back to point A. So the best way to solve the problem, I'll tell you what we can do. Just imagine first situation, second situation, third situation, fourth situation. I'll just show some circles just to make you understand. It just started. This is going with V. This is going with 2V. Where will they collide? Think about it. Where will they collide? After how much angle will they collide? Think about it like that. Okay. If you are able to guess it, very good. If you are not able to guess it, no problem. This is moving with v, this is moving with double the speed. So this will cover double the angle as this one. This will cover double the angle as this one before they eventually meet. So imagine this moves x, this will move 2x, but the total angle by the time they meet somewhere should be how much? 360 degree. Should be basically 360 degree. So if this ball goes x amount, this would go 2x amount before they meet. This would go 2x amount before they meet. And x degrees plus 2x degrees is 360 degrees. So 3x is 360 degrees. So x is 120 degree. So if they start their journey together in opposite directions, after how much degree will they meet? 120 degrees they will meet. And one thing is standard, guys. If there are two masses going in the opposite directions with speed v and 2v, after the collision, this guy's speed will be 2v and this guy's speed will be v. They will exchange their velocities, right? They will just what? Exchange the velocities in elastic collision. In case of elastic collision, this is the property for equal masses. Use this concept over here. These masses will finally come over here. You will see one is coming like this and the other one is coming like this with 2v and v speed. Where? At 120 degrees. This is just before the collision. After the collision, you will see they would have exchanged their velocities. So this will get 2v speed and this will get v speed. This will get v speed. Correct? Now this is just like this diagram, v to v. So what will happen? This will move more angle, this will move less angle, and after 120 degrees they will meet again. 120 degrees relative to this. That means they should meet over here. That means they should meet over here. So think about it. Think about it. They have covered 120 degrees and they will meet over here. This 2v will come like this. This v will come over here like this just before the collision. Just before the collision. They will again exchange their velocities. This guy will have v velocity and 2v velocity will be there over here. Perfect. Now this diagram is just like this diagram. So this will move more, this will move less, this will move more, this will move less, and you have to cover 120 degrees so that they meet again. You will see that this 2v would come here, approach like this. This v would approach like this so that they would have moved 120 degrees again. That's it. This is the final time where they come back. So guys, they have collided once here and they have collided second time over there. So there are basically two collisions before they meet at point A. Before they meet at point A. This was the first collision, right? This was the first collision which happened. This was before, this was after. This is again before and this is after. This is the second collision. After this would be the third collision. After this would be the third collision. So gone from here to here to here to here to here and so on and so forth. Beautiful question, isn't it? The concept is only very nice. Let's go ahead to the next type of questions on gravity. Two particles, distance d apart, third particle in between. No resultant gravitational force. Question is, what is the distance of the particle from m1? Let's draw the diagram to understand what is happening. There is a mass m1 here and a distance d apart. You have placed mass m2 somewhere and you have kept a mass over here. You have kept a mass over here. There is no net gravitational force on that mass which is kept. On the mass which is kept, right? So you have kept a third particle on the line joining them and there is no resultant force. Meaning what would be happening is this m1 would be attracting it with force 1. This m2 would be attracting it with force 2. These both are equal. That is why the net force is 0. That is why the net force is 0. What is F1? What is F2? Well, for that, let's assume this as x distance. This will be basically d minus x. This is d, this is x, this is x minus d minus x. F1, can I say it is g m1m divided by x square, g m1 m2 by distance square. What is force 2? g m2m divided by d minus x whole square. G and m got cancelled. So m2 I can bring it down. So m1 by m2 will be, or else we'll do one thing. Let's take d minus x square on the top. So d minus x whole square divided by x square. This bring it on the top. m1 you shift it down. m2 you keep it as it is. gm has got cancelled. Take roots on both sides. So d minus x by x is equal to m2 by m1 whole thing under the root. So take separate out the denominators and numerators like this, split the terms. So d by x minus 1 is root of m2 by m1. Shift 1 on the other side. So d by x is equal to 1 plus root of m2 by m1. Take LCM, so this will become root of m1 plus root of m2 by root of m1. So what will x be equal to? Shift x on the top, take these two people below. So x will be equal to d root m1 by root m1 plus root m2. That should be the answer. That should be the answer. Yes, d root m1 upon root m1 plus root m2. This is the correct answer. Cool? Splendid question. Wow. Wow. Looks like we are going to have a matchmaking process very soon. Guys, very good. Let me tell you, the kind of relationships that you might get over here is nowhere comparable to the relationships that you might get when you get out of IIT or NIT or any other government college. So please stop wasting time. Be a Sigma. Don't be a Gamma or something. Really. Whatever nonsense you are doing here is of no use. Nor are you going to get the Insta ID, nor are you going to get any pleasure, nor are you going to do anything great by doing this nonsense over here. So might as well study, go to a good college, and definitely you will get much better options than whatever you are getting over here. Yeah, cool. Let's move on to the next one coming up on your screen. And here it is. Find the depth and the height from the surface of Earth where acceleration due to gravity is half the value of the surface. Question on the formula application. Let's do separately. First, let's go down, then let's go up. When you are at depth d, the gravity formula is g 1 minus d by r. Because this is given to be half, so I'll put g by 2. 1 minus d by r. This is g on the surface, d is the depth, r is the radius of the planet. G cancels. Half is equal to 1 minus d by r. So d by r, 1 minus half is a half. So d will be basically r by 2. R I take it on the top. So r by 2 I can see either in b or in a. So it should be one of them, either a or b. For the next part, for the one on the top, when you go on the top, the gravity at height h is given by gm by r plus h whole square. Gm you can also write it as gr square. That's the standard formula. Gm is gr square, r plus h whole square. But this gravity is given to be again half the value on the surface. So gh is g by 2 is equal to gr square by r plus h whole square. G cancels. Take roots on both sides. So 1 by root 2 is r upon r plus h. Shift it. So you will get r plus h is r root 2 cross multiply. Okay, and that's what I have done. So therefore h will be r common root 2 minus 1. R common root 2 minus 1. That is option number A. Cool? Everybody? Yes. Very good, Sanjay. Meena? Yes, Dhanalakshmi. Very good. Sir, after 10th, I would want to take, sir, please tell me, what do you want to take Bunny with Bunny all-in-one shots? What do you want to take? Please tell me. PCM, PCMB, engineering, what do you want to take? Coaching. The change in the value of G at a height h is the same as depth d below. Both are smaller than the radius. Which is correct? Which of the following is correct? Okay, cool. So think about it, my dear warriors. What will the formula be? When you are going down, the gravity at depth d is g into 1 minus d by r. Take g separately over here. So, or else you can do one thing, take gd on that side. So g minus gd, this gd by r, take it on the other side. Gd by r, take it on the other side. This is change in the gravity when you go down by some depth. So that comes out to be g into d divided by r. This is the formula. But when you go on the top, but for a small height, the formula is not the same. The formula is not the same. Don't use this big nonsensical formula. Use a smaller formula which comes after some derivation using binomial approximation. I have given that to you in the formula session also. That comes out to be as g 1 minus 2h by r. So what you can do is just keep g as it is over here, bring that gh over here, bring g 2h by r on the left hand side. So g 2h by r over here. G minus gh is delta g, is nothing but 2gh by r. As per the question, is the change in the gravity is the same whether you go below or whether you go on the top. As per the question, is the same. So that means this is the same as this. So basically these two should be equal. So what will you get? Gd by r from here is equal to 2gh by r. Gr cancels. So what will you get? D is equal to 2h. D is equal to 2h. Where is it? Option number D. Got it? D is equal to 2h. Very good. No, today is only 11th, right? I had mentioned this clearly in the launch video also. And then we had planned to do 12th problems. Cool. Let's keep it fast, guys. Coming up on your screen. Here is the next question. The radius of a planet is n times the radius of the Earth. A satellite revolves in a circle of radius 4 nr with angular velocity omega. The acceleration due to gravity on the planet's surface will be how much? That's the question. Think which is the formula which we'll need. Clearly it is mentioned that the radius of the planet is n times the radius of the Earth. So new planet has more radius, n times. Satellite revolves around it in a circle of radius 4 nr with some angular speed. And the acceleration due to gravity on the planet's surface, g on that planet, will be how much? Okay, so if angular velocity changes because the radius has changed, can I relate it to g? I think so. See, whenever a satellite is going around a planet, there is a centripetal force which is acting because of gravity, and it causes centripetal acceleration as it revolves with some angular velocity omega. So can I say the gravitational force is m into omega square into radius r. So this radius happens to be 4 nr, 4 times nr, and the gravitational force will be g, mass of the planet, mass of the satellite, upon basically 4 nr. That's the distance of the planet till the satellite. Two planets distance, it's nothing but, yeah, this one, right? So what will I do? I'll do one thing. Small m cancels. Gm will be omega square. Take this over here, 4 nr whole square over here. It will become 4 nr whole cube. Now this is the interesting part, because what is capital Gm? I use that substitution even over here. If you realize, Gm is gr square. Gm is gr square. It's a standard formula which you should know. So I can just write it as g into planet's radius square is equal to omega square. Oh, but wait a minute. The planet's radius is also n times of Earth. So what do? Should I put G into nr whole square? Should I put G into nr whole square? No. This Gm stands for, understand, the acceleration due to gravity on Earth into basically the radius square of the Earth. This is a standard formula. Capital Gm is small g r square is a standard formula. Understand? Irrespective of what planet you are taking, you always use it as a constant and write it as small g into radius of Earth whole square. Always. So this will be equal to your omega square and 4nr whole cube. Is that clear, my dear warriors? Is that clear, my dear warriors? Very good. So now you just have to substitute it over here and you will get the value of G on that particular planet. So just solve this and you are going to get it. What is the answer that you get, my dear warriors? You can see 4 cube. Automatically you can see the number over here. 4 cube is nothing but 64. Yes, you should get the answer as 64 over there. 64 over there. Perfect. Clearo? Shall we move ahead to the next question coming up on your screen? Right. What is the minimum energy required to launch a satellite of mass m from the surface of the planet of mass capital M, radius r, in a circular orbit at an altitude of 2r? That is the question. Yes. So let's see if we can do this. Let's see if we can do this. First of all, you are having a mass on Earth on the surface, and then finally what you want to do is place it in the orbit. Place it in the orbit over here. When you are on the surface, the potential energy only is there. There is no kinetic energy. So the total energy which is there initially without kinetic is nothing but minus Gmm by r, nothing else. When you bring it on the orbit, the total energy of a satellite is minus half Gmm divided by the radius of the orbit. It's clearly mentioned that the altitude is 2r. The altitude is 2r. That means the radius is basically 3r. So this will be 3r over here. Standard formula for the energy of a satellite. It is minus half Gmm by 2 into radius. Yep. Is that clear? Very good. So now what will you do? Now what will you do? Just take the difference of these two. Just take the difference of these two. Because that difference is what is the energy what you need. So the delta E value will be nothing but minus Gmm by 2 into 3r minus Gmm basically by r. So Gmm by r is common, minus minus becomes plus, and this minus is there as 1 by 6. 1 minus 1 by 6 is 5 by 6. So 5 Gmm divided by r. That is what you will need. Yes, correcto. Yes, 5 by 6 Gmm by r. 5 by 6, sorry, the 6 was there. 5 by 6 Gmm by r. Is that clear? Everyone with me? Cool. Shall we move ahead to the next one? Here it is. The work done to raise the mass from the surface of the Earth to a height which is equal to the radius of the Earth is how much? Okay. Very similar question, just that the difference is here the mass was in orbit. The mass was in orbit. That's why you use this formula for the energy of a satellite. But here it's not in the orbit. You have just taken it till height h. So the work which is done is the change in the gravitational potential energy. The gravitational potential energy at height h is minus Gmm by the distance, which is r plus h, and initially it is just minus Gmm by r. So when you are at a height which is equal to the radius of the Earth, r plus r will make it 2r, minus minus will make it plus. So Gmm by capital R. So this will become 1 minus half, which is half. So it will become half Gmm divided by R. But the questions options are not having capital G. But wait a minute, Gm is gr square. Remember that constant which I told you is nothing but gr square into m. divided by basically 2r. R cancels. I'll have mgr divided by 2. mgr divided by 2, which is option number B, of course. Option number B. Is that clear? Shall we move ahead? No, it is not D, it is option number B. Be little bit careful. Be little bit careful. Yes. Let's move ahead to the next question coming up on your screen. The escape speed of a body which is thrown up is 11. If the body is thrown at an angle of 45 degree, then what do you think is the escape speed? Then what do you think is the escape speed? That's the question. Come on, think about it, my dear students. Think about it, my dear students. What do you think is the answer going to be? It doesn't matter. Exactly. Very good. Some of you got it. No, these are not PYQs. This could be inspired from PYQs, but some of them by coincidence might be PYQs, because last 3-4 years you see there are like, every year we have close to 10 to 15 shifts, so many questions, right? So some things might get repeated here and there. Yeah, so it does not depend on the angle, it does not depend on the mass, it just depends on the mass of the planet, right, and the radius of the planet. That's all that matters. Yeah, correct. Okay, right. Now the next question says the two particles of equal mass go around in a circle under the action of mutual gravity. The speed of each particle is how much? How to do this particular question? This is an exclusive problem solving session. If you want to watch any of the concepts, you can watch any of the older classes, number 1. Number 2, there is a link in the description box. At 999 rupees, you can take the crash course. You can clear all your concepts over there also. Both the options are there with you, okay? So in those crash course classes, concept and problems happen. But if you think that no, I want to see only from YouTube, that option is also there with you. Where all my older classes, I have explained all the theory part, everything. This is exclusive problem solving. You're just 2 weeks away before the exam. Now is not the right time to teach all the concepts from all the chapters. If you have a need for a particular chapter, watch that video or use the crash course video. Both options I have given you. So over here, when these two particles are separated by some distance and they are going in a circle of radius r, they are going in a circle of radius r, okay? So let's say this is the center. This particle goes like this with some speed. This particle goes like this with some speed. They are going like this. This is going like this. Okay, they are going in a circle like this. Okay, I just shown their motion. Why are they able to go in a circular motion? Because they attract each other, number 1, with some force. That force acts like the centripetal force. You have thrown it with some speed, the force is there. So the speeds are always perpendicular to the force, and that force is always attractive because of gravitational pull. So these two masses always keep pulling each other by gravitational pull, and that acts like the centripetal force, which changes their direction, does not change their speed. So I can simply say my F is equal to m into centripetal acceleration. That force between them is G, M, M, both the masses are equal. Distance is, please mind it, it is not r, but it is actually 2r. It is actually 2r, right? It is basically 2r. Be little bit careful over there. The two masses are separated by 2r, diameter as the distance. Mass into centripetal acceleration. Centripetal acceleration, I can just write it as v square by the radius of the orbit. Okay, small mass, one of the r just gets cancelled out. So what am I left with? Gm is there, 4 is also there, 1r is there, v square is there, this r has cancelled out. So therefore v is equal to root of gm by 4r. Root of gm by 4r. So that 4 can be taken outside as 2. 4 can be taken outside as 2. No, it is not B option. Meena, yes, game over Tamil. It is option number C. Correct. Moving ahead to the next question coming up on your screen. Okay, we are going to center of mass and rigid body mechanics. Beautiful question. Two masses are going at an angle over here. Okay, on inclined planes. The question is, if both of them are left, what is the combined center of masses acceleration? Because these two masses go on the inclined planes, they will have their own accelerations, which is just given by g sine 45 and this is also going to have basically g sine 45, correct? Each of these g sine 45 will have components, one vertically, and one horizontally, like this. But the horizontal accelerations will not cause any motion of the center of mass. This mass goes like this, this mass goes like this, components are there. The horizontal motions are opposite and equal. They will not cause the center of mass to accelerate anywhere, but the ones in the vertical direction, that will cause the center of mass to go down vertically only. So it will definitely go vertically down. Upwards does not even make sense, eliminate it. So what is this acceleration? It will be g sine 45's 45 component or cos 45 component, which is g 1 by root 2 into 1 by root 2, which is basically g by 2. So this is g by 2, this is g by 2. Even this is going to be g by 2. So what will the center of mass come down by? G by 2, which is 10 by 2, which is 5. So the acceleration will be 5 meters per second square. 1 second. Now this is where I wanted to tell you that there will be a catch over here. And a lot of people make a small mistake saying that, sir, this is g by 2, this is g by 2. So the answer should be, 5 meters per second square. But you need to be little careful over here. That when you are taking components, right, this y component that you are going to get, I don't know why they have not given over here as 5. It should have been 5. I think they have made a mistake over here, guys. Ignore this. I don't know why they made a mistake over here. This is my g sine 45 component, smooth double inclined blocks, and this was the component of that. Yeah, so guys, the answer is 5 only. It is not 10. Ignore that. This is 5. Now the thing which I wanted to tell you is, sir, can I use this formula? ACOM is nothing but M1A1 plus M2A2 by M1 plus M2. Yes, you can use this. No problem. But it will unnecessarily be lengthy. Reason being, this mass is equal, this mass is equal, this mass is equal. Both the masses are same. This is also M, this is also M. So M cancels. So you will have A1 plus A2 by 2. Now A1 and A2 themselves are equal to each other. A1 and A2 themselves are equal to each other. So it will become 2A1 by 2. Basically, it will become A1. Why are the accelerations equal? Because masses are equal, angles are equal. It's a symmetrical scenario. So you will get the center of masses acceleration as A1. So there was no need to do this lengthy method. I hope this is clear. Is that understood? There was no need to do this lengthy method. So both these masses were going down like this. It will have one horizontal and vertical components. These horizontal components, no use. If they go like this, what is the point? They might just keep on going like that. The center of mass will neither go there nor go here. Because both the masses are going down, the center of mass will also come down along with it. It will also come down along with it. Keep this in mind. So this component will be g sine 45's cos 45 component. That's why g sine 45 into cos 45. Understand this? So we have the acceleration. We are taking a component of that acceleration. How much is that y component? So that is why it is this guy's cos 45 component. This is your A1, which is also equal to A2. This is your A1, which is also equal to your A2. Is that clear? Everybody understood? Very good. Very good. Thank you, Pradeep Srinivasan. Great. Let's move ahead to the next question. Here it comes. A semicircular ring of mass m and a disk of mass 2m are joined together as shown. Find the center of mass from the geometrical center. This is a very unique kind of question because many of you would have seen circle is there, square is cut out and all those things. This is a semicircle and then there is a semicircle, but it is solid. So like a disc and a ring, where would the geometrical center be? The ring has a mass of m. So let me put m over here. The disc has a mass of 2m. Be careful. The disc has a mass of 2m. Now, where does the center of mass of a disc or a ring lie? Remember, there was a formula. If you have an arc, and in this case, the arc subtends pi radians, the center of mass for a ring, this distance is given by r sine theta by 2 by theta by 2. Sine 90 is 1, so 2 goes on the top, so it will become 2r by pi. But if it is a solid disc, this angle is pi radians, the center of mass will be here. It is at a distance of 2 by 3 r sine theta by 2 by theta by 2. 2 goes on the top, becomes 4 by 3, r sine 90 is 1. 4r by 3 pi. That is the answer. 2r by pi and 4r by 3 pi for a ring, and this is for a disc, semicircular disc. Use these in the previous problem. So basically you will see this distance is 4r by 3 pi by 3 pi, and this distance is just 2r by pi. This distance is 2r by pi. So you have now converted it into a 2-point mass system separated by certain distance. This is the y coordinate up and this is the y coordinate down. Masses are also given. Where will the center of mass be? So just use our normal regular formula. From the geometrical center you have to find a distance. So the y coordinate of the center of mass will be m1 y1. So 2m into y1, which is 4r by 3 pi, into m2 y2. So plus m into y is negative, so minus 2r by pi upon m1 plus m2. That's it. So 2m plus m. M cancels everywhere. So you will have 8r by 3 pi minus, here you will have 2r by pi, whole thing divided by 1 plus 2 is basically 3. So you can see the LCM over here is 3 pi. So it will become 8r by 3 pi minus 6r by 3 pi, the whole thing divided by 3. So you will definitely get 9 pi in the down denominator. 3 pi into 3 will make it 9 pi. 8r minus 6r is basically 2r. So basically 2r by 9 pi should be the answer. 2r by 9 pi should be the answer. Yes, it is. There you go. Perfect. Got it, everyone? Yes, we have finished more than 50 plus questions, if I'm not wrong. Yeah, 50 plus questions, 100% we would have finished. A similar kind of question can also come where you have taken out something or you have added something and then you have to find where the center of mass lies. These kind of questions are also common. I'll just give you the hint for these kind of question. What you need to do is you need to use the formula x center of mass is m1 x1 minus m2 x2 upon m1 minus m2, where you have taken out something. Now you are worried, what is x1, what is x2, what is m1, what is m2? M1 is the total mass, m2 is the removed mass, the mass which has been taken out. Because it's a circular disc, the masses are proportional to the area. So mass 1, which is of the entire circle, will be mass per unit area, I can call it sigma, into the total area, which I can say pi r square. Mass 2 is the mass which has been removed over here. See, think about it. This is radius r. This is side. This is also side. This is also side. This is also side. The radius is the diagonal. The radius of the circle is the diagonal of the square. So remember, the diagonal was always root 2 times the side. So therefore, what will the side be? Diagonal by root 2. What is the diagonal? R. So the side length is basically r by root 2. So what is the area of it? Side square. So r by root 2 square into sigma will give me mass of the square. which comes out to be sigma r square by 2. I got to know m1, I got to know m2. Is this point clear how we found it? Mass will be proportional to the area, more the mass. Always write in terms of density. If you are worried, sir, what is this sigma? It's mass per unit area. Will it bother me? No, because when you finally substitute it here, everywhere it will get cancelled from numerator and denominator. So don't bother about it. Lastly, what is x1 and what is x2? x1 is the coordinate of the center of mass of the entire circle, which is the origin. So it is 0. What is x2? Is the center of mass coordinate of the square. It is here. If this is r by 2. So I'll just put r by 2 over here. x1, x2, m1, m2. Everything you know, substitute, you will get the answer. After substituting everything, you will get the answer as r by 4 pi minus 2. You will get r by 4 pi minus 2. Is that clear, everyone? Yes, very good. Awesome. Let's move on to the next question coming up on your screen. A ball of mass 50 grams is dropped from certain height. It rebounds, losing 75% of its kinetic energy. If it remains in contact with the ground for this much time, what is the impulse of the impact force? This ball was dropped from certain height. It rebounds to it rebounds losing 75% of its kinetic energy. That is very important. So if the kinetic energy was K, when it rebounds, the kinetic energy was K by 4, because it has lost 75%, 1/4 is only remaining. 1/4 is only remaining. Correct? So if the speed over here was V, kinetic energy becomes 1/4. Kinetic energy is half mv square. Speed will become V by 2. How did I realize this? Think about it. Kinetic energy is half mv square. So 1/4 kinetic energy will be 1 by 2 m nu speed square. Because the kinetic energy has been 1/4, speed will have to become half. If you don't agree, just substitute it over here. Just substitute k as half m v square, which is half m nu v1 square. So half m cancels. So v square by 4 is v1 square. So v1 is v by 2. So if it hits the ground with speed v, it will rebound back with speed of v by 2. So to find the impulse j, which is change in momentum, it's mass into final velocity, which is v by 2, minus mass into initial velocity, which is v, but there is a catch. Put a minus sign here also, because impulse is a vector, even momentum is a vector, signs have to be considered. Many people miss the minus sign. mv by 2 final momentum, mv initial momentum, but opposite in direction, so minus of that. So minus minus becomes plus. mv by 2 plus mv is 3 mv by 2. Mass you know, velocity you know. I think you can find the answer. Velocity is root 2 gh. Mass is 50 grams. So velocity is root of 2 gh. Height you know, 10 meters, right? Mass you know is 50 grams. Substitute everything. You will get the answer as 1.06 as the answer. Cool? Will you be able to substitute and get it? Understood the concept behind it? Main problem happens here. Second problem happens here, that many people read it as the final energy is 75%. Rather than reading, it loses 75%. So only 1/4 of the energy is left. 1/4 of the energy is left. Right. Very good. Let's move on to the next question coming up on your screen. A wooden plank is basically resting on the floor. A man of mass 60 kg starts moving from one side to the other side. Find the magnitude of the displacement over the floor when the man reaches the other end of the plank. This plank man questions are very, very common. Let me tell you that. So let's visualize this quickly. So there is this plank whose length is basically 10 meters, and there is this person over here. Okay, and the mass of the person is 60 kg and the mass of the plank is 20 kg. So what happens, as soon as the person moves, the plank moves behind. The plank moves behind, right? The center of mass has to be conserved. It will stay there. So when the person reaches here, the plank has moved here. The person moved here. The plank has moved here. That's all. Question is, find the magnitude of the plank's displacement if the person goes to the other side. First of all, realize this. If you sit on the plank and observe the entire motion from plank frame, the relative displacement of the person, displacement of person with respect to the plank, is displacement of the plank, person minus displacement of the plank. V12 is V1 minus V2, A12 is A1 minus A2, S12 is S1 minus S2. That relative displacement, imagine you are the plank, you look at the person has gone 10 meters ahead. Yes, you have gone little bit behind, but for you on the plank, the person has moved how much meters? 10 meters. For the ground, it is completely different story. From here to here, the person has moved 10 meters relative to the plank. So this 10 is nothing but S1 minus S2. Another formula which you need to use is for plank person problem or balloon monkey problem is M1 S1 plus M2 S2 is equal to 0. Mass 1, mass of the person is 60. Displacement, I don't know. Mass 2, 20. Displacement of the person, plank, I don't know. This is what the equation will look like. Perfect. So 60 S1, so cancel 20. So this will become 3 S1 plus S2 is equal to 0. Rather, S1 will become minus S2 by 3. S1 will become minus S2 by 3. Substitute it over here. Instead of S1, put it as minus S2 by 3. That's all. What will you get? Minus S2 is equal to 10. 1 by 3 plus 1 is 4 by 3. So minus 4 by 3 S2 is equal to basically your 10 out here. Perfect. Right. So this will basically cancel over here. This will become 2. This will become 5. So S2 will become minus 15 by 2, which is minus 7.5 meters. So the plank will go 7.5 meters behind because the person has moved ahead. Here, if you ask me what is S1, S2, these are the actual displacements of the person and the plank as observed from the ground frame. If you sit on the plank, you will only see the relative motion. So the person has gone from this side to this side. The separation between them is just 10 meters. That is why S12 I put it as 10 meters, nothing more, nothing less. Okay, I hope this is clear. Shall we move ahead to the next question? Here it comes then. 7.5 meters, yes. The moment of inertia is given as this. The body is at rest. In order to produce a rotational energy of this much, the angular acceleration must be applied about the axis for a duration of t seconds. Find the value of that time. That is the question. Okay. So, first of all, inertia is given. Rotational energy of 1500 is also given. Angular acceleration is also given. Question is, how much time do you need to apply it? So kinetic energy formula is half I omega square. We know this. Kinetic energy is 1500. Moment of inertia, well, that is 1.2. Omega, I don't know. Bring it on the top. So this will become 3000 is equal to 1.2 omega square. So omega square will be, bring it over here, 30,000 divided by 12. I can write it. If you want, this will become 4. So this will become 10 to the power 4 by 4, or omega will be 10 square by 2, which is 50. Omega is 50. Once I get omega, I can find the acceleration and time relation, because by kinematic equation, final angular velocity is initial angular velocity plus acceleration into time. Final is 50, initial is 0, alpha is 25, time I don't know. So t will be 50 by 25, which is basically 2. So the answer will be 2 seconds. Yes, it is 2 seconds. Perfect. Got it, my dear students? Amazing, right? These questions are very good. Let's move ahead. We are trying to practice as many questions as possible. A certain block, some mass, hits another block, unknown mass. If it is elastic and the first block continues to move with 3 what is the mass of the other block? Just draw the diagram and use conservation of momentum, I feel. So 172 grams moving with 5 meters per second. It's another unknown mass which is at rest. After the collision, this 172 grams moves with 3 meters per second, and the second block, what does it do? That is not even given to me. Okay, question is find this mass. First things first, use this concept that relative speed of approach is relative speed of separation. Since E is 1, separation speed is equal to approach speed. They are separating with a speed of v minus 3. Both are in the same direction, so v minus 3. They are approaching each other with a speed of 5 minus 0. So basically v will be equal to 8 meters per second. That is the first thing that you get. Next thing, use conservation of momentum. Mass, which is 172, into velocity, which is 5, plus no momentum. Mass 172, velocity which is 3, plus mass unknown, velocity basically 8. There is nothing over here left, which is just mass which is unknown. 172 into 5, 172 into 3, bring it on this side, it will become 172 into 2, and then divided by 8, right? You will get the answer as 43 grams. Just check this out. If you are getting the answer as 43 grams, basically you will get 172 into 5 minus 172 into 3, the whole thing divided by 8, which is 172 into 5 minus 3 is 2 divided by 8. This will go 4 times. Just check it out if it is 43. Yes, it will be. 43 into 4 is 172. Yes, 43 grams is the answer. Cool? Clear? Shall we go ahead? Right? Moving on to the next question coming up on your screen. There is a disc which is free to rotate, and what is happening is the axis is perpendicular to the plane passing through the center. Torque is being applied. Acceleration is given. The net acceleration at the end of 2 seconds on the rim point, that means on the tangential point, on the circumference. What is the acceleration? Alright, so let's try to do this problem. Guys, if you are going to do some time pass, you will be blocked. Guys, be careful about it. Yeah, remember that. No nonsense will be tolerated here. Yeah. So what do we do for this problem? Acceleration is given. Torque, okay, is applied. So from this, the first thing we can find is tangential acceleration, which is alpha into r. Is the radius given? Yes. Alpha is 2, radius is 0.5 meters. So it is 1 meter per second square. Okay. Next, I need to also find centripetal, because there will be both kinds of acceleration. It is rotating, so it has tangential as well as centripetal. So what do we do? How do we find centripetal? For that we need omega. For omega, what we can do is omega is equal to initial angular velocity plus alpha into time. Alpha into time. Alpha is basically 2, time is 2, so omega is 4. Okay, so centripetal will be omega square r. Omega is 4, so 4 square, r is 50, 0.2, 4 square 16, right? Yeah, sorry, 0.5, why did I write 0.2, 0.5, yeah, 16. So this will be 8 meters per second square. Now comes the final part, which is the total acceleration, which will be centripetal square plus tangential square, whole thing under the root. So 8 square plus 1 square, which is root 65, which is approximately 8, which is approximately going to be 8. So answer will be, because question said approximately, so I can put it as option number C. Make sense? Yes, very good. Yes, very good. Clearo, clearo. Very good, very good. Keep it up. Moving ahead to the next question coming up on your screen. In this diagram, there is some ring which is rolling without sliding with some speed on the surface. All surfaces are smooth. B has no speed. What will be the maximum height reached by A on B? Wow, very nice question. This is based on conservation of momentum and stuff like that. Conservation of momentum and stuff like that. So you have to think over here that what and all principles, what and all formulas you might need, and what might exactly happen when it reaches on the top. Right now, only this mass, right now, it is only rolling with some speed, this ring with on the horizontal surface. Everything else is smooth. All surfaces are smooth. B has no initial velocity also. So this kinetic energy will slowly be converted into potential, is what you might think. But be little careful, because there is no friction involved, no external force. So whatever is the momentum should also be conserved. So right now this mass is moving, this is at rest. So there is a momentum towards the right as a system. So when it goes on the top also, there must be some momentum towards the right. There must be some momentum towards the right. So even when this guy reaches over here, this entire system will still be having some velocity. So conserve momentum, conserve the momentum in x direction. Initial momentum is just mv. This B block is at rest. Final momentum, ring has a mass of m, and I think both of them have the same mass, if I'm not wrong. Yeah, same mass as A, correct. So m plus m into u. M plus m is 2m. It cancels over here. So you will get u as v by 2. So even when it has reached on the top, both of them are continuously moving with the same speed. You can think of it like this. This ball has reached here. It still has this velocity. This also has that velocity. So that is v by 2. So this u comes out as v by 2. That means there is still some kinetic energy left. Everybody with me? Very good. So now what about the rolling motion? Because it is rolling, there will be also some kind of rotational kinetic energy involved, and the best part is this rotational energy will not go only anywhere, because all the surfaces are smooth. No way you can change the rotation. Whatever rotational energy was there here, the same rotational energy is there here also. So kinetic energy of rotation is there here as well as here. There is no change because all surfaces are smooth. So now let's write down the energy equation. So initially half mv square translation is there, plus your rotational kinetic energy is there, which will not matter only because anyways it is not changing. Then when you go on the top, still that rotational kinetic energy is still there, but translation wise only this component horizontal is there. There is no vertical motion because it has reached the maximum height. So plus half mu square, plus this block also has gained some energy. This block has gained half mu square amount of kinetic energy, and this ball has gone up by height h. So mgh. Now u is basically v by 2. Instead of u, you can put v by 2. Instead of u, you can put v by 2. That's it. So you can see kr and kr just got cancelled over here. This and this just got cancelled over here. Shift all these people over here and cancel out m, right? Later on. So mgh will be half mv square minus half mv square by 4 minus half mv square by 4. You can cancel. From this you will get the height, solving it as v square by 4g. Okay, just check this out. You can cancel out this m. Just do the math. You will get this this height as v square by 4g. That's all. Main thing is you should realize rotational energy did not change. Although rolling was mentioned, no concept of rolling was actually involved over here. Second thing, momentum will be conserved in the x direction. So when it reaches on the top, still there is some momentum in the x direction. So all these things were there in this problem. Another beautiful question. This is the last question which we'll be doing, because after this you will have Navamita ma'am's class. Yeah. Just check this out. Answer is C, Vishu. Just check this out. Answer comes out as A. This will be v square by 8, v square by 8. So that will make it v square by 4. So 1 by 2 minus 1 by 4 will be 1 by 4. No, it is option A only. It is not option C. I think you would have made some mistake. Just check it out. Okay. Mass of the rod is given. It is hinged at point O. It can freely rotate. Question is, the particle sticks to this rod, the angular speed just after the collision. Whenever rotational things are there, particles are sticking, hitting, etc., and it begins to rotate, instead of linear momentum conservation, it will be angular momentum conservation. That's all. I'll give you the idea about this problem. So initial angular momentum will be equal to the final angular momentum. Now, what is the initial angular momentum? This mass is going along this line. This is your R perpendicular. So remember the formula, mass into perpendicular distance, which will be now d by 2, into the velocity, which is v. This is initial. What about the final, guys? This whole thing will behave like one single system. It will have some moment of inertia, so into omega, because all these things will rotate together with some angular speed. What is that moment of inertia going to be? Well, it will have two things: moment of inertia of the rod plus the moment of inertia of that small m mass, because it is getting stuck over here. Is that right? What is the moment of inertia of that small m mass? It is just m into distance square, which is d by 2 whole square. What is the moment of inertia of the rod? It is hinged at the center, so it will be mass length square by 12. What is the mass of the entire rod? It is given as 6m. So it is 6m L square by 12. That's it. This equation will directly tell you what is the value of omega. So that value of omega comes out as 2v by 3d. Exactly the same thing has been done. Cool. So the omega is 2v by 3d. Amazing. Yeah. So now, my dear students, shall I share the PDF of the remaining problems as well? Yeah. Do you want the PDF? One thing I need: comment and like. And join the Telegram channel. So if you are not yet aware where the Telegram channel is, just as you are watching this particular video, go in the description box of this particular video, right? Where is it? Yeah, this one. What just happened? Go into the description box, yeah, of this particular video. Okay, and you can see join our Telegram channel. Just click on this link, Vedantu JEE English. Over there I'll be sharing the PDF of all the problems for all of you. We have discussed many problems, and like you saw, solving each and every problem takes a lot of time, and we have justified that time also. It's not like just because for the sake of doing it I have done it. Whatever time was needed for every problem I have given for that. Okay, so remaining problems, please take it up as homework. I'll be posting the solutions also of that. Okay, I'll be posting the solutions also of that in the same PDF. Okay, so make sure you download the same. Bye bye. Thank you so much. All the best. Now attend Navamita ma'am's class. Okay, and tomorrow you will be having one chemistry and one maths class, and day after tomorrow we'll be having a mock test. Okay, so take care. Bye bye. Captain Shreyas signing off. Hasta luego.